Tell me when. We're live now? Yeah, okay. Hello, Internet. So if you're tuning in now on YouTube or Facebook, this is CS50 for MBAs, wherein we take a top-down approach to fundamentals of computer science as opposed to the bottom-up approach that we take in the Harvard College class that focuses more on the hands-on. This is our fourth of several shoots for CS50 for MBAs. It's completely behind the scenes, so we might start and stop, but please bear with us. Otherwise, in a few weeks' time, the same version, more edited, will appear online on the Internet. We're here with Arturo and Dan and Scully and Ian and all of you at home. Up today, web development. All right. Ready when you are. All good? What's that? Yeah, I think we'll start over here again. Camera one first? OK. All right, good if you are. Okay. What's that? What? OK. So by now, you probably understand how the Internet itself works, and recall that we've discussed how payloads, how packets are transmitted from points A to B across the Internet. But we haven't really dived in deep into what's inside of those packets just yet. We did make mention that inside of those packets, if they are being sent via the protocol called HTTP, is a language called HTML. A markup language, not a programming language, in which web pages are marked up, that is written. In other words, when you make a web page, you have to write in a certain language. That language is called HTML, Hypertext Markup Language. And it's not a programming language in that it doesn't have loops and conditions and functions and so forth. It's a markup language in that it has tags, tags that tell the browser how to display your information, tags that tell your browser how to format information, and ultimately how to render a whole web page. In fact, let's go ahead and do this. Let's start right off by making our very own web page. But much like with Scratch, where we had an environment in which to begin programming, so with web pages are we going to need some kind of environment with which to create those web pages. Now, we could on a Mac use TextEdit. We could on a PC use Notepad.exe. You could even use something like Microsoft Word if you saved it in the right format. But that would not be generally the best thing to use, as in the case of programming languages are their best tools to use for the trade. And so we're going to use, in this case, an environment called CS50 IDE, which is based on an open source platform called Cloud9, which is a web-based IDE, integrated development environment. Now, what does that mean? That means much like in the Scratch application where you had a place to write code and to see code and to run code ultimately, so in CS50 IDE do we have that same ability. But rather than programming with puzzle pieces, here we are going to write web pages using this language, HTML, and using ultimately my keyboard. So here's what CS50 IDE looks like when you first open it up, perhaps. You'll see on the left-hand side a folder containing any files that you might have. And of course, the first time you use the environment, odds are you won't have any files whatsoever. In the top here, we're going to have a big area where we can open up tabs in which to edit files, like our HTML files. And at the bottom, we're going to have something called a terminal window, which we won't necessarily need all of the time. But it's this terminal window that provides you with low-level access, a command line access to the underlying computer, which in this case is a Linux computer running an operating system specifically called Ubuntu. And long story short, what you have in CS50 IDE is a cloud-based service. Someone else out there happens to be running in Amazon's cloud, for instance, is running a whole bunch of servers on which you will ultimately have an account. And within that account, can you write files and then view them on the World Wide Web. So let's make our very first web page. I'm going to go ahead and do the following. I'm going to go ahead and create a new file by clicking this plus and saying new file. I'm going to go ahead and save it as, say, hello.html. And in this file, I'm going to go ahead and do the following. Open bracket, doc type HTML, sorry, open bracket, exclamation point, doc type, HTML. And then down here, I'm going to do open bracket, HTML, close bracket. And you'll notice something fancy just happened. Even though I only typed the first half of that line, the second half sort of magically appeared. And that's because CS50 IDE, like a lot of integrated development environments, will try to finish your thought for you. It will infer from context what you're probably going to type after whatever it is you just typed to try to help you type fewer keystrokes ultimately. And indeed, you'll see soon that this was exactly what I was going to type ultimately. But first, I want to type a few more things as well. Inside of this red tag, so to speak, HTML, I'm going to do open bracket, head, close bracket, it too, finish that thought. And in here, I'm going to do open bracket, title, close bracket, and then a simple title like hello, comma, world. I'm going to go ahead then and below this head tag and do open bracket, body, close bracket. Again, my thought is completed. And I'm just going to write for now the same thing, hello world. Now let's tease apart what in fact is going on here. Well, the very first line of this file is the so-called document type declaration. This is just a simple line that you can pretty much copy and paste that just tells the browser ultimately, hey browser, here comes a web page written in specifically version 5 of HTML. HTML has been around for some time now. And humans have constantly been changing it, have been improving it. And so we're up to we're up to HTML version 5. And now here, below that, are a whole bunch of seemingly red tags, as I keep calling them, that are sort of like directives to the browser. Each of these tags tells the browser really to start doing or to stop doing something. So here on line 3, we see open bracket, HTML, close bracket. This is like telling the browser, hey browser, here comes that web page that I promised. And so accordingly, you might be able to infer now that on line 4, insofar as it says head, this is like the file telling the browser, hey browser, here comes the head of my web page, the sort of top of my web page. And then after that comes the body, so the rest of the web page. So much like we humans have heads and bodies, top and bottom, similarly do web pages have heads, which are generally encompassing the title bar, or like the topmost area of the window, and then the body, which is really the essence of the page itself. But with that noted, hierarchy. So much like the head of the page is inside of the HTML page itself, so is the title inside of the head of the page. Now, what is the title of this page? Well, even if you've never seen HTML before, you can probably infer that the title of this page is going to be literally hello world, our sort of go-to sentence whenever we need some initial words. And as for the body of the page, very, very little going on here. But here we have in the body of the page just hello world. So at the end of the day, this is going to be a really simple web page, but it's going to ultimately say hello world, both in the title, across the title bar, the tab, as well as in the body of the page itself. Now, not all of these tags are like the others. Some of them say open bracket something, close bracket, but a few of them have open bracket /, then the word, then the close bracket. So here's a // // And notice, as the hierarchy kind of suggests, these are symmetric. If HTML is the first tag that I opened, notice how it's the last tag that I closed, so to speak. Or you might say start and end here. And so together, everything between those HTML tags, open and close, start and end, is an element, an HTML element. And inside of that, of course, are two elements, head and body, each of which is defined by a start tag and an end tag. And then the head further has this title element with its open and close tag. So not all HTML tags, we'll see, are going to work quite as symmetrically as this. Some of them don't really need end tags, and we'll see some of those exceptions, or you might encounter some more on your own. But this general paradigm is really what defines HTML. It's just some pretty explicit tags that you don't have to write in red. This is just CS50 IDE highlighting in red those tags so that they stand out vis-a-vis the actual content, like hello world of your web page. But you're pretty much, when writing HTML, just telling the browser what to do and telling the browser when to stop doing that. Hey, browser, that's it for my title. Hey, browser, that's it for the head of my page. Hey, browser, that's it for the body. Hey, browser, that's it for the web page itself. Now, what is this thing going to look like ultimately? Well, if I open up this file, not in CS50 IDE per se, but in an actual browser like Chrome or Safari or Edge or the like, I'll actually see the following. That's it. It's an incredibly underwhelming web page at the moment. You'll see that just the body is there. And I've actually full screened my page here. And so if I actually hover up to the top here, we'll see that indeed the URL of this page has hello.html at the end. And that lives on this server in the cloud. But it's that hello.html file that I myself just wrote. Of course, if all your web page does is say hello world, you're really not going to have many repeat visitors, shall we say. And this is certainly underwhelming when it comes to what you can do on the web as we all know it. So what more can we do with HTML and how? Well, let's go ahead and enhance this just a little bit and go about using this as a building block for more sophisticated examples. So for instance, let's go ahead and add, say, a cat to this page. Let me go ahead and create a new file, and we'll call it cat.html. No, new file. And give me 1 second to fix an error where otherwise going to copy. Yeah. So I realized the title of the tab has to stay, so I figured there we could mask that out. I'm not going to have to do that often. Actually, let's rewind. So I wanted to show that the tab bar also said hello world, which I actually forgot to mention explicitly. So the tab itself says hello world.
What do you want to appear in the bar? Just nothing?
Oh, I think we'll canonicalize this as like cs50.io/hello.html, just to strip out all of that.
Okay.
Or we'll just mask it out altogether. So let's actually, let me rewind. Let me re-mention this, because I wanted specifically to point out that the title has this too. Okay. And actually, so yeah, let's rewind. And then we'll segue to the images. OK, 1 sec. Let me open this file. Hello. Come on. OK. OK, so I want to transition now to mentioning what we're going to see in the browser here. So to do this, let me go ahead and do the following. Copy this. That looks stupid. OK, let's do this too big. OK. Next. Sorry, give me 1 second. All right, so I think we transitioned here to opening this file on a web page. So if we actually open this up in a browser, that's what we're going to do. OK. All set. So if we actually now open this file in a browser, here's what we should see. Here, for instance, is a Chrome window. I've opened up hello.html in this browser window. And sure enough, notice at the body of the page, do I see hello world? And at the top of the page in the tab is the head, specifically the title, which, of course, is hello world as well. But this, of course, isn't all that interesting. There truly isn't all that much going on in this particular example. So let's actually begin to use some of the building blocks that you yourself have seen in existing web pages on the web and see if we can't spice things up just a little bit. So for instance, the first thing I can think of doing is maybe writing a web page that has an image inside of it. So let me go ahead and copy what I've just done initially. Let's create a new file here, and I'm going to go ahead and call it image.html. I'm going to start with the same contents as before, but this time I'm going to just do image. And I'm going to do down here a new tag. So again, we have more tags than just HTML head, title, and body. For instance, we have an image tag, which isn't spelled quite like you might expect. The humans like to be succinct, and so img is the name given to the image tag. But how do I specify an image? Well, before today, I went ahead and, as I'm wont to do, went on the internet and found a whole bunch of cat photos. I downloaded one, and I called it cat.jpg in my server's directory here. But in order, sorry, I need the cat. Copies, cat. Yeah, we'll do that. Image. OK, I need this transition to there. Something more interesting. So first, let me go ahead and create a new file. And I'm going to call this one, say, image.html. And in advance, I've also had the wherewithal here to spend a little bit of time, as I am wont to do, to download a photograph of a cat from the internet, which I've called here cat.jpg. And my goal at hand now is to spice up my first web page into my second by embedding in it this cat photo, as you might find elsewhere on the internet. Now, to speed things up, I'm going to go ahead and just paste the contents of that previous page. I'm going to retitle this as just image. But now in the body of the page, I want to have not text like hello world. I want to actually have the image of a cat. And you might be inclined to just do something first like cat.jpg. But of course, that's not going to put an image there. That's literally going to put the letters cat.jpg there. So I don't want that. So I probably need some other tag to say, hey, browser, put an image here. So how might I do that? Well, it turns out that much like there's an HTML tag, a head tag, a body tag, and more, there is an image tag, though not quite spelled as you might expect. Humans like to be succinct, and so instead of calling it image, it's just img. But this, too, isn't kind of obvious yet as to how I should specify what image to put there. Well, it turns out that HTML fundamentally supports not just these tags or elements, but also attributes thereof. In other words, you can influence the behavior of a specific tag by passing it essentially a key value pair, formatted as attribute equals, quote unquote, some value. And so in this case, it turns out, succinctly again, that the source of my image, not spelled source, but src, should equal, quote unquote, as promised, cat.jpg. Now, it doesn't quite make sense to close this tag and then put something there, and then rather to close the start tag, put some words, and then close the tag itself, because the image is really either there or it's not there. There's really no notion conceptually of starting an image, doing something, and then ending the image. You either start and end the image all at once, or you don't put it there at all. And so I don't want to do this. I instead want to tell the browser, you know what? This is an empty element. It has no content, no children nested inside of it. And so I can actually put that / inside of the open tag, but at the very end, just like that. It's not strictly required, but it should make more clear the fact that we do indeed have some balance here. Everything that is opened is also eventually closed. So let me go ahead and save this. Go ahead and open my browser again. And this time, we see in image.html a very grumpy cat. Now, there's some minor aesthetics here you might notice. There's like this big white border around it, and that's just because the browser's default is often to put a bit of margin around it. We can control that if we want. But at the end of the day, all this adorable web page has is an image embedded inside of it. So what's really going on here now in the context of the internet itself? Well, again, CS50 IDE is in the cloud, so to speak, and it is running a web server. And that web server is what's spitting out these web pages requested via HTTP. So when I just visited this page, something/image.html, that's like my laptop having sent one of those virtual envelopes inside of which is a message like, get me image.html, get being that operative capitalized word or verb from our discussion of the internet itself. And the response that's coming back from the web server, specifically CS50 IDE, is apparently an HTML file called literally image.html. And the browser, upon receiving that file, is showing me not the text inside that file, but rather, because the browser knows that anytime a file ends in .html, it should actually parse the file, read it top to bottom, left to right, and then show me the rendered version of the page, the visualization of what that markup is telling the browser to do. So as before, when the first example was just telling the browser, say browser, print out hello world, now the web page, image.html, is saying, hey browser, put an image here, the source of which happens to be cat.jpg. And again, I uploaded in advance cat.jpg to the server. I could have uploaded any number of photos, maybe ones that I took on a vacation, or maybe something that I found with someone's blessing online. But the point is that both the HTML page and that image live on the server. And so what is the browser actually doing? Well, let's do this. Let me go ahead and open up Chrome's inspector, as you might have seen before, and open up the network tab specifically. And let me go ahead now and reload this page and see what happens. Well, at the bottom here, you'll see that index.html is the first. Now at the bottom here, let me get rid of this. Do this again. So as you might have seen before, let's open up Chrome's inspect window, and then specifically the network tab. And let me go ahead then and reload the page. And what you'll see is that 3 HTTP requests just happened. Specifically, if I zoom in here, the first HTTP request that my browser sent was for a file called, as we expected, index.image.html. And luckily enough, all is well, status 200. And remember, that is the opposite, so to speak, of 404. 200 means OK, all is well. So that's good. And then notice the browser pretty intelligently sent a second HTTP request to the server saying, hey, browser, get me cat.jpg as well. Why? Because the HTML file referenced it. And so this is what's nice about web pages in general. You don't have to put everything in the file itself. Rather, you can reference other files like cat.jpg, and others we'll soon see. And the browser is smart enough, when it parses that HTML file, reads it top to bottom, left to right, if it notices the name of other files or other URLs, it will automatically download those as well so that everything can be displayed all at once. Now, I don't like the looks of this last one, this red one, favicon.ico. It turns out that there's a convention on the web such that if your server has a file called favicon.ico, most browsers will display it to the user, typically in the tab these days, so that next to the title of the tab is also some image that came from the server. Now, we've not gotten that far. We've not created our own custom icon as harvard.edu might have, a Harvard crest up top. We have no such file, and that's to be expected then that we don't get 200 for that request. We instead see 403, which means unauthorized, which is to say the browser can't find the file, and it also doesn't seem to be authorized to even access the file because we haven't even created it in this case anyway. And so the browser is just presumptuously, and in some sense incorrectly, requesting this file now. But again, it's become convention, if not protocol, to actually look for this file. So that in and of itself, not worrisome at all right now. Well, let's go ahead and do a couple of more examples to see what more HTML can do besides just images of cats on the internet. Let's go ahead and make an example this time involving a link. Let me make a new file. I'll call it link.html. Let me start with the content that we have here, just so that we don't have to retype it all. We'll rename or retitle this page link. And instead of having an image like this, let me go ahead and create our own web page that has a hyperlink, so to speak, to some other website. Specifically, let me go ahead and do this. Search for a href, quote unquote, and now follow along if you could, https://www.google.com/search ? Q = cats, close quote, close bracket, cats, period. Whew. So a bit of a mouthful, and I did know what I wanted to type there, so I did it pretty quickly. But let's see if we can't visually parse this and then look at the result in a web browser. So in the body of this page is apparently the sentence, search for cats. But what's going on there? So I have just some English here, search for, and then notice cats is here, and then the period. But interspersed in that sentence is some markup. And so indeed, we can have inline markup, inline HTML, whereby it's interspersed with actual content or text that we want to display on the screen. This tag here is a new one. It's the anchor tab, also abbreviated as just A, probably because it's just so common. This is how you make an anchor or a link in a page. href, little cryptic, but it means hyperreference. So this means to what file or to what URL should this link refer or go to. And then the URL in question, I kind of made this one up off the top of my head, though I've used this certainly before. Turns out that if you search for cats on Google, essentially, this is the URL that Google ends up bringing you to. And I've deleted some of the distractions that might otherwise be the additional parameters in the URL. But then after the close quote is the close bracket, and then in white here, CATS. So it turns out this is how you make a hyperlink in a web page. You have the text of the link here. Cats is going to be what the human sees. But in the href attribute, do you put the URL to which you want to link? So there's this duality here. And now that I've saved the file, let me go over to my browser and visit link.html. And we'll see a super simple web page. Indeed, it's super small by default up here, search for cats. But notice, as is the case in browsers, they tend to have a default color scheme and formatting mechanism for links. In this case, it's blue and underlined. And so that's very enticing. Let me go ahead and move my mouse over the word cats and click and hold my breath. And indeed, we have a whole bunch of cat search results. So this really is the essence of the web, and really the overarching purpose originally of the web, to hyperlink related resources. And so I can lead the user from one place to another place on the internet. In this case, it just happens to be a destination of cats. Now, we can do so much more. And indeed, what's exciting about HTML is that, frankly, at this point in time, we pretty much know all of the fundamental structures. There are so many more tags or elements that we've not yet looked at. We'll take a look at a few more. But in general, learning HTML is much the process of reading up online, looking at how other web pages are made, and generally keeping up with the times as new features are added and new versions of the language have come out over the years. But what's important is this fundamental structure of web pages, having a head and a body, having tags specifically, some of which can have attributes, and closing those tags as is appropriate. The rest is just building up our vocabulary. So let's go ahead and take a look at a few prefabricated examples that just hint at the expressiveness of HTML and some of its additional features. Can I impose, do you mind trying to grab like a bottle of water or something downstairs, or a cup? I think I'm losing my voice, and I want to hang in there. Sorry. I'm going to move the files into place in the meantime. It doesn't have to be water, whatever you can find. Or worst case, I'll text someone. Is it OK if we pause for a second? I just don't want my voice to give.
At the end of each one, before we cut, can you do a debrief with the camera of any notes that you have in your head?
Yeah, sure.
Together, because we're stacking up with like 4 to 6 of these.
OK. Yeah, there's just been that one remark so far about the URL. What's that?
I saw the touch bar phone pop up too, which we restarted as well.
Oh, really? I didn't see that happen.
Here.
Oh. Oh, thank you. That's perfect. All right, let's hope this works. All right. OK, ready when you are. Boom! Look at all of these examples here. And let's just begin to scratch the surface of some of these new features. First, let me go ahead and open headings.html, which I've written in advance. And you'll see shares a similar structure with a doc-type declaration up top, off screen, than the HTML tag here. And I've been a little more precise now. I've taken the recommendation of folks on the web and actually specified what language this web page is written in, just so that if the browser has any language-specific features, it knows by default what it is it's dealing with. Now, the web page itself is pretty simple. The title this time is headings. And the body, though, has some slightly different text. It apparently says 1, 2, 3, 4, 5, 6, but each of those words is wrapped in a heading tag, H1, H2, and so forth, all the way down to H6. Now, at first glance, you should have no idea what these tags are going to do other than somehow display the words 1 through 6. So let's go ahead and just open this up in my browser and see what it says. Voila! 1, 2, 3, 4, 5, 6. So for some reason, it gets super small by the end of it. But indeed, that's the purpose of these headings. So much like a textbook tends to have chapters and sections and subsections and so forth, often which are typically formatted in sort of decreasing size to sort of convey their decreasing status as a section heading. Similarly, is H1 through H6 meant to be used for exactly that kind of purpose, where H1 is typically big and bold, as for the start of a chapter or the title of some document, whereas H6 is much smaller, but still bold-faced, thereby conveying some semantic meaning as well. So what else can we do with HTML besides this? Well, let's go ahead and open up, say, paragraphs.html, which show a page that follows the same structure fundamentally, but now has a web page that follows the same structure, but now has a bit more content to it. Specifically, we have the HTML tag as before and the head tag. This time, though, I've been a little proactive. I've added a meta tag. And there's actually a number of different use cases for these meta tags. In this case, it's essentially making this web page mobile friendly. It turns out when you make a web page, typically by default, if you open it up on like an Android phone or an iPhone, it actually might seem super small. And not just because the device is small, but because the web page doesn't necessarily know that it is being viewed on such a small device. So via this line here, this meta tag whose name is viewport, can I actually proactively tell a browser, as on an Android phone or an iPhone, to dynamically resize itself somewhat to make the text bigger, knowing that the device screen is smaller than it might usually be. Now, in the body of this page is 3 new elements, all of which are the same, paragraphs. And again, abbreviated as P, not paragraph written out. But indeed, we have an open tag and a close tag, inside of which is just some placeholder Latin text that has no semantic meaning here, but it's just a nice placeholder to show if you want to have 3 separate paragraphs, you can separate them with these paragraph tags. Let's take a look. Inside of paragraphs.html is this effect here. You indeed see the line break, as is apparent here, and you have 3 of these things total. Now, it's worth noting the following. HTML and browsers in turn will only do what you literally tell them to do. So if I do not tell the browser to make 3 separate paragraphs, as with this trio of open and close tags, and if I remove those tags, go back to this web page and reload, notice what happens. In CS50 IDE, I still had those Latin paragraphs as distinct paragraphs, such that I had hit enter a couple of times to give line breaks in between them. But HTML, and in turn browsers, take things very literally. If you don't tell the browser, put a line break here, or if you don't tell the browser, make this a full-fledged paragraph, it's not going to for you. In fact, it's going to look at any white space, so to speak, any tabs, any carriage returns, any spaces in your web page. And if you have multiple such spaces in a row, the browser is typically, by default, going to ignore all of that white space except for just one instance of it, one space and not two, one space instead of multiple new lines. And so here, everything seems to be blurring together incorrectly because I haven't told the browser literally what I want it to do. However, if I restore those tags as they once were, save the file and reload, now I have back the 3 paragraphs as was intended. Well, let's take a look at a couple more examples. For instance, this one here in list.html. This too, similar structure. So notice the pattern that's starting to emerge. But this time in the body of the page, do I have UL, which succinctly stands for unordered list, and inside of which is a whole bunch of LI elements. List item, list item, list item, inside of which are 3 arbitrary words that computer scientists tend to use when they have nothing else to say, foo, bar, and baz. Much like X, Y, and Z might be used by default in algebra. And so here we have an unordered list of 3 elements. And it's unordered in the sense that it's going to be rendered by default in a browser, typically with bullets, one after the other, as opposed to seeing the number 1, then the number 2, then the number 3, which would be an ordered list. So for instance, if I go ahead and open this list.html file, we should see exactly that, 3 bullets, foo, bar, and baz. However, if I proactively go in here and change this not to an unordered list, but an ordered list with OL, and then reload the page, notice that the browser automatically handles the numbering for me. And this is nice as a feature, much like Microsoft Word and Pages and other editors can do this too when you're writing an essay or a document. So can a web browser figure out for you how much data you have and then render or number it accordingly. Let's look at a slightly more involved example for a table. Now, the example at hand is kind of arbitrary, so let's actually look at the result and then work our way back as to how we did it in table.html. You might notice on your phone, you have a keypad typically that looks like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then some symbols along with 0 at the bottom. And this is laid out, it would seem, in rather tabular form. But how can I get everything to line up in these 4 rows and 3 columns? Well, I can do this with HTML. Let's go ahead into the file itself and see if we can't read this top to bottom. So we have the body of the web page as always, inside of which now is a table tag. So hey browser, here comes a table. And then a little cryptically, here's how it's laid out. TR stands for table row. So this is like saying, hey browser, here comes the first of my rows. And then inside of that is 3 TD tags, table data. And this is pretty much like saying, hey browser, here comes 3 columns, or cells really, within a row. TD1, TD2, TD3 mean put it at the top left, the top middle, and the top right. And then, hey browser, that's it for the first row. This close TR tag means that's it for the first row. And of course, right below that is another TR tag that says, hey browser, here comes another row, a second row. And that's how we get the 4, 5, and 6. The 7, 8, and 9, and then the star, the 0, and the pound sign. And so the net effect, to be clear, is this. So at some point, the nesting can become a little involved, and the pages are getting a little more complex. But again, if you look at each piece in isolation and build up this page via baby steps, so to speak, much like in Scratch, where you wouldn't want to necessarily implement a whole program all at once, you want to implement individual features of a web page, one piece at a time, can you begin to build up all the more sophisticated examples. And indeed, let's go there right now. Thus far, all of these examples have been very static. Even the example involving the link to some Google search results was kind of sort of dynamic, but it was someone else's dynamism. But we can make our web page even more interactive than just a blue underlined link. In fact, the most common UI, or user interface mechanism on the web, is probably an HTML form, something that has a button you can click, or a drop-down menu you can choose from, or a text box that you can type into. I mean, odds are most every day you use some aspect of a form, whether it's to search, whether it's to submit some information to a website, whether it's to log in, or any number of other use cases. So how can we now, using our understanding of HTML fundamentals, re-implement like the super simplest front-end interface to something like google.com? Can we build our own Google, but use Google's database so we don't have to build the whole thing ourselves from scratch? Well, I dare say we can. And I'm going to go ahead now and create a new file called, whoops, one sec. I'm going to go ahead and create a new file called search. Cleaner edit. I'm going to go ahead and create a new file called search.html. Just to get me started, I'm going to paste my original hello world example in there, but I'm going to quickly start to change it as follows. Inside of the body of this page, I'm going to go ahead and use a new tag altogether called form. I'm going to specify that this form has an attribute of action, where action is going to be where this form should submit its information. I know just from experience that I can send information to, for instance, www.google.com/search. And the method I want to use, if you recall from learning a little something about HTTP, is that the method I'm going to use is gets. A little confusingly here, it should be written in lowercase instead of all caps, but it's this one and the same, that same verb that we've seen inside of the virtual envelope sent from a browser to a server. Now, inside of this form, I'm going to have a couple of inputs, one of which is going to have a name of Q, because it turns out, as you might have glimpsed from that cat example, turns out that Google search uses an HTTP parameter, an input, in its URLs called Q for query, the value of which is whatever the human has typed in. So it turns out I can do value, now the type of this input, we'll see, should be text, because it's something the human's going to type in. This, as we'll see, is just going to be a text box. Does not need a close tag per se, so we'll keep it an empty element with that slash inside of the very same start tag. But I'm going to want one other input. This one is going to be a different type. It's going to be a button whose purpose in life is to submit the form by default to a server. And the value is just going to be, something like search. And similarly, while I close that one. If I now save that and open my browser to search.html, you'll see it's a super simple interface. It's not nearly as nice as Google, though frankly Google doesn't have all that much more than this. They just have a little bit more formatting and a little more color, and everything is centered. But I dare say this is the essence of google.com's homepage, wherein I can search for most anything on the web. This is a text box, and so I'm going to move my cursor over that. And this time, let's make a more interesting result so it doesn't all look prefabricated. Let's go ahead and search for dogs this time. So I've typed in this input to the text box. I'm now going to click the other input, which again is a submit button, click search, and voila. I have made a web page that somehow submits information that the user has typed in to another web page. And if I look at the specific URL that I'm now at, as by going out of full screen mode, notice that the URL I'm at is indeed www.google.com/search Q for query equals dogs. And so this is what's powerful about understanding these fundamentals of HTTP and now HTML, is that you can begin to reconstruct so many of the familiar features that we've seen. And indeed, though there's a lot more complexity visually on a web page like this, you can start to imagine perhaps how Google is structuring things underneath the hood, or how your favorite website is actually built in HTML. I mean, maybe this is some kind of paragraph here and another paragraph here. These blue links, they lack underlines, but maybe they're still hyperlinks, because I certainly know from experience I can click on these search results and end up at other web pages. So it would seem that there are ways to customize the aesthetics of a web page so it doesn't look quite as boring as all of my own examples thus far. And now over here, clearly, there's a whole bunch of image tags, it would seem. So here, too, Google's using some of these same fundamentals, but they've got a lot of experience. They've spent a lot of time laying everything out. So there's certainly a more rich user experience here. But we can learn even from their experience. In fact, as before, let me go to Chrome's inspector by right-clicking or control-clicking on the web page itself. And instead of going to the Network tab, let me stay on the Elements tab, which is typically the default. Now, there's definitely way more tags and attributes here than we've seen. But let me go ahead and just zoom in on this. And you'll notice what Chrome and other browsers are really good at doing is parsing HTML and not only showing you the web page, as we're seeing a moment ago with all the dogs, but you can also see what's going on underneath the hood. And even if Google's HTML source code, so to speak, is really a mess. And maybe there's very little indentation, very little white space, such that it just looks like a big blob of text. Chrome and other browsers will pretty print it for you and even syntax highlight it, so to speak, using these disparate colors that aren't in the file itself. It's just being displayed as such so that the tags and the attributes and the text all jump out separately. And even though Google is a pretty well-oiled machine, notice that they too just use these same fundamentals that you perhaps now understand all the better. HTML tag, head tag, body tag. Some tags for sure we haven't seen yet. Div, which is like a generic container, a rectangular region of the page called a division that you can then style, as we'll see, as you see fit. No script and script. This has to do with actually adding programming code in a language called JavaScript. More on that in just a bit. And then if we scroll down further, we'll see more and more content down here. A lot of divs in their particular page, but we can zoom in on any of these elements and actually see. For instance, let's do this. This second link here, dogs from Animal Planet. Let me control click or right click on that, click inspect, and what's really cool is that Chrome and other browsers will immediately jump to that element in the page. And notice we can infer how this page is structured. Besides all these divs, which are just, again, creating these rectangular regions, notice here's an H3. So that's sort of like one of those medium-sized headings that Google's using. Inside of here is a href. And now notice, this is kind of a crazy long URL, but it turns out if I click that URL, it's going to redirect me to dogs on Animal Planet. It doesn't seem to be animalplanet.com, though, which is a little suspect. I do see animalplanet.com here, but notice there's all this craziness up front. Well, it turns out that often, though not necessarily always, companies like Google are actually going to monitor what links you're clicking. So in a simple world, this href would just be animalplanet.com/dogs or whatever the URL is. But no, this URL actually, as implied by this slash at the very beginning, is actually referring to Google's own servers. So even though you might think, OK, Google knows what I searched for, but they don't know what I'm clicking on because they don't have a partnership with animalplanet.com, perhaps. Even when you click these search results, are you sometimes going to find yourself going back to Google and then ending up at animalplanet.com? It just happens so fast. You don't realize that Google just logged what you clicked on. Now, why would they do that? Like, why add this intermediate step between you and the destination you care about? Well, 1, analytics. 2, making search results better. 3, advertisements potentially. In any of these cases, Google is gleaning more information from your behavior because now they know they just showed you 10 results relating to dogs. If you clicked on the second result before you clicked on the first result, maybe the results weren't that good. Maybe for subsequent visitors who also want to search for dogs, maybe they should start showing the Animal Planet link first instead of the actual first link that you saw. And so here there can be a nice feedback loop, but again, realize there's a privacy implication. But by understanding how HTML works and by understanding the simplest of tags and attributes, can you kind of deduce for yourself what is going on, or are you indeed comfortable with such yourself? Now, Google's web page is, of course, so much more visually interesting than any of the things I've done thus far. And that's in part because they're better designers, but also in part because they're using a language we ourselves have not looked at yet. It turns out that intermingled in HTML, in many, if not most, web pages today, is another language called CSS, Cascading Style Sheets. Now, what does this mean? Well, it turns out that though we focused on the canonical web page looking a little something like this, with tags and attributes and actual text, for instance, it turns out that there's some other tags we haven't yet seen, but that Google and others are certainly using. One of which is the style tag, which can go in the head of the web page alongside the title. And it's with this style tag that you can actually implement some fancier aesthetics. You don't have to just go with the blue underlined default links that a browser typically gives you. You don't have to just go with big, bold, black text for H1 and small, bold, black text for H6. You can override those settings as well, just like Google apparently has with their H3 tag. It turns out, too, you can also embed these styles not in the web page itself, but in a second file. But we'll get there in just a moment by way of these examples. So let me go into CS50 IDE, And let me go ahead and open up css0.html. CSS, again, denoting cascading style sheets. And let's take a look at this example. It's a pretty simple web page for a guy named John Harvard who has 3 components to his web page. And there's many different ways I could implement this page, but I've tried to mark things up, so to speak, in a semantically compelling way, in a self-descriptive way. So this web page, inside of the body, has 3 main sections. One called header, one called main, one called footer. And I didn't make those words up. It turns out in HTML5 there are these and yet other tags that you can use to structure your page and actually provide hints to the browser as to what is the main part of the page, what is the header of the page, not to be confused with the head of the page, and what's the footer of the page. These 3 things, header, main, footer, all belong inside of the body of a web page, as per the definition of HTML. But notice what I've done. And it's not great practice, so we're going to have to clean this up. But notice in the header of my page, I have John Harvard as the owner of this home page. In the main portion of the page, it says, welcome to my home page. And at the footer, it's got his copyright, John Harvard, 1636 or whatnot. Now, what do you see that's different here? Well, odds are a new attribute is jumping out at you, style. And notice this is indeed an attribute. It's not a tag that we saw a moment ago foreshadowed in the CSS example. So we'll come back to the distinction there in a moment. But you can perhaps infer what this style attribute is doing. As the name suggests, it's styling the HTML element. So it's changing the aesthetics of it from the default. And you can probably infer from this green or yellowish text that the first header has a font size of large, whatever that means, and the text alignment should be centered. Meanwhile, the main part of the page should have a medium font size, also centered, and the footer should have a small font size, also centered. So let's look at the spoiler. What is the net effect of all of these attributes? Well, it's to create a web page that, arguably the nicest of the ones we've done thus far, still pretty simple. But we have here John Harvard, it's pretty big. Welcome to my home page, kind of medium. Copyright John Harvard, it's a little smaller. So 3 relative sizes, but all of them are centered. So it turns out what we have just done and what you have just seen is an example of CSS, cascading style sheets. Specifically, these are CSS properties, the format of which is some property name, literally a colon, and then the value thereof. And if you want to have multiple properties, multiple key value pairs, so to speak, you just separate them by semicolons. And just for good measure and for symmetry, I kept a semicolon on the end. It's not strictly necessary, but this way all of my properties has the same structure in all 6 of these distinct locations. So that's kind of nice that it follows this pattern, but it's also a little messy in that now I've got HTML, I've got English, and I've got CSS. It's all just kind of getting very sloppy, I would say. And there's also some redundancy here, right? Like if you take a look at these 3 styles, there's a commonality to them. Text align center, text align center, text align center. Wouldn't it be nice if we could somehow factor that out and not type it identically 3 separate times? So indeed there is. If I open up a slightly different version here, CSS1 now, notice the page is structurally the same, but I've cleaned it up a little bit. And how have I done that? Well, notice I'm leveraging some inheritance, so to speak, insofar as the body tag is a parent, so to speak, of header, main, and footer. It's a parent conceptually in that header, main, and footer are all inside of that element before it's closed, later on down here. But aesthetically, too, it's also in parent, as per my indentation, that it's also a child, too. It's indented inside of the body tag. Though, again, the browser doesn't care about indentation. All this indentation and nice, pretty spacing is just for us humans to better visualize things. But what's key is that I factored out this commonality up here to a style attribute on my body tag. And insofar as that is the parent of these 3 children elements, header, main, and footer, that text align center now applies by the definition of CSS to all of those children. So I've cleaned things up a little bit. Now if I want to left align or right align my text, I just change it in 1 place and not 3 places. And that's representative of the kind of thought process and design process that goes on. Never write something 3 times, let alone copy paste something 3 times, if you can design it better and factor that out and write it, for instance, in just 1 place. But we can do better. In fact, I am not loving how I am now commingling my data, my text in English here, with my metadata like main and footer and header, and the stylization thereof. One, this feels just kind of messy that I'm commingling my data with the presentation of it, so to speak. Two, it's going to make it harder for me to work with like a colleague who has a much better sense of design than I. And it would be really nice if he or she actually wrote all of the CSS properties, deciding on the font size and the colors and the spacing and the alignment, and just let me assume that they will take care of that much more beautifully than I could. And three, it just makes it really annoying to maintain, because now if I want to change the aesthetics of my web page, I have to go searching through my file, which for fancier web pages is going to be much longer than this relatively short file, and it just doesn't feel very maintainable, so to speak. So let me propose CSS2, our third version, 0 index to be clear, where I've done the following to the HTML. I've kind of reworked it, and you'll see that there's no mention of CSS per se now. Notice instead I've introduced a new attribute, which also exists in HTML5, called class. And class is a way of defining groups of one or more CSS properties that can apply to any number of tags or elements in a web page. So for instance, and I could have named these things anything I wanted, but I came up with what I think are pretty compelling, pretty semantically appropriate names for these classes. Body is going to have a class of centered. Header is going to have a class of large. Main is going to have a class of medium. Footer is going to have a class of small. Again, could have called that foo, bar, and baz, x, y, z, but none of those would really be descriptive. So I've instead invented classes called centered, large, medium, and small. And I deliberately chose large, medium, and small to line up with the font sizes. But also just conceptually, I want it large, then medium, then small. So it kind of flows conceptually as well. But what is centered? What is large? What is medium? What are small? These are words of my own creation technically here. I need to scroll up to see what these classes actually look like. Notice here now is that style tag, not attribute. In the head of my web page is a style tag, inside of which now are 4 keywords: dot centered, dot large, dot medium, and dot small. And the dot is deliberate. So sort of odd though it is, the dot signifies that this is the name of a class. So class equals quote unquote something corresponds to dot something when defined up here inside of the style tag. Now you can kind of read what's going on here. The only piece of new syntax really is these curly braces, which we've seen in other programming languages perhaps. So dot centered has the following group of properties: text align center, semicolon, so just the one. The large class has a font size of large. The medium class has a font size of medium. And the small class has a font size of small. And that's it. If I now go into this web page in a browser and open it up, aesthetically, it's still exactly the same, but now it's better designed, arguably. But you know what? This creation of classes doesn't even feel necessary, because notice I already have kind of uniquely identifying words in my web page. Again, to be fair, this is a pretty simple web page, so I'm kind of getting lucky here. But notice that if I already have a tag called header that completely encapsulates John Harvard, and main already exists, and footer already exists, like this feels kind of lame that I also need to come up with 3 arbitrary but descriptive words like large, medium, and small, just to stylize these tags, which already have unique names. So it turns out that with CSS, cascading style sheets, you don't have to use just style attributes or a style tag with classes. You can also select, so to speak, select being an operative word in the CSS world, you can also select elements by way of their name, not just some class on them. So in fact, let me go ahead and do this in our final example here, or our fourth example here of CSS3. And you'll see in this file that I've now removed the class altogether. Now this web page is getting really, really tight. Like I am only using as many characters or words as I strictly need to make this web page happen. And honestly, just at first glance, look how much more readable the page is without these longer lines, without all these style attributes. Like now the data in the page, the content, John Harvard, welcome to my web page, copyright John Harvard, is really jumping out at you. And yet we're still styling it in fundamentally the same way, but this time using a different selector. If I scroll up to the top here, notice now I don't have any mention of the dot. I just have the word body, which corresponds to the HTML tag called body. I have the word header, corresponds to the HTML tag header, and main and footer, the properties inside of which are exactly the same, but I haven't introduced unnecessary overhead of classes. Classes have value. They do have value, especially if you want to reuse them elsewhere and your web page is more complicated than mine. But the key here is that even though we have all of these building blocks, we don't want to necessarily build the biggest web page we can. It's often compelling to build at least close to the smallest web page if that lends itself to better readability, just easier for me to read it and understand it. If that lends itself to better maintainability, if I and a colleague can now collaborate on this because there's just fewer distractions and there's fewer lines of code to maintain and fewer lines of code to potentially make mistakes in, all of this is pretty compelling. But what isn't really compelling is how I'm still kind of commingling my CSS properties with my HTML. Indeed, in this and many contexts in the world of technology, computer science, and programming, there's this generally accepted practice that you want to separate your data from your presentation. Like the contents of this web page have nothing to do fundamentally with the bold facing, the font sizing, the coloring of that actual content. That should all be kept separate for any number of reasons, one of which is just, again, the maintainability of it long term and the cleanliness of the files. So as per our canonical example a bit ago, in CSS4, do we introduce this other tag that you might have just glimpsed called link, which remarkably confusingly is not a hyperlink. It is the way in which you tell a browser to load another file, a .css file typically, that contains your CSS properties to be applied to this file. So it's not a hyperlink. That's the anchor tag, the A tag as before. But the link tag in the head of a web page allows you to specify this: an href, which references the file you want to include. Again, not link to, but pull in. And then the relationship, which is style sheet. So theoretically, this link tag could be used for any number of things, but we most commonly see it used for style sheets. So I've pretty much just written this verbatim and then changed the name of the file that I've created. And the file I created in advance, just to keep things kind of named similarly, is css4.css. Let's open that file, css4.css. And in this file, do you see pretty much the exact same contents of our previous example, but no style tag, just the text of that CSS selector, body, and its property with the curly braces. And then the same for header, main, and footer. So at the end result is if I open up css4.html, just like 0 and 1 and 2 and 3, do we see exactly the same thing? But again, the progression here has been toward better and better, or cleaner and cleaner, design of the otherwise correct content. Let's look at one final example, CSS5. So in this case, I've not done anything all that new except to link to a third part. Nope, we're going to skip this one. Unnecessary. All right, let me take a water break. Testing, testing, 1, 2. All right. All right, ready? All right, so we've only scratched the surface of the actual tags that exist in HTML and the actual properties that exist in CSS. But again, we've covered the fundamentals, what the structure of a web page is, what the structure of a CSS property is. And so from here on out, filling in the blanks really amounts to looking at an online reference, a printed book, looking at existing websites, Googling as needed for answers to questions, because what you now hopefully have in your toolkit is a fundamental understanding of what a web page is, how you can structure it, and how you can go off and continue to add features. But at the end of the day, these pages still, with this toolkit, remain pretty static. You know, we have kind of some dynamism insofar as we can send users to other websites that might look much better than mine, and we can send users input even to something like Google, and let Google's database provide more information for the user from its own search engine. But wouldn't it be nice if we could have a little more interactivity on our own website? And wouldn't it be nice if we could maybe make sure that the user has typed something in correctly before we just blindly send it over to some server? And it turns out that even though HTML is not a programming language, again, it's just a markup language that tells a browser how to render information, doesn't have logical constructs like loops and conditions and variables and more, and just as CSS, too, is not a programming language because it, too, lacks those capabilities for the most part, there's another language that we can introduce here. And indeed, the front end of the World Wide Web, so to speak, what you and I as humans see, is typically composed these days of a trio of languages, HTML and CSS, and the third is JavaScript. If you've heard of the language Java, no actual relationship. It's simply similarly named. But JavaScript is the de facto standard for web browsers when it comes to writing programs that run not on the server, but in the client's computer, so inside his or her own browser. And this is what makes it a little different from languages like C and C++ and Java pretty much, and other languages still like Python and Ruby, which are typically, though not necessarily, executed server-side. In a browser, JavaScript is the language to which you have access. And so how do we go about writing programming code in a web page? And frankly, why would we want to do that? Well, let me go ahead and open up this example here. DOM0. DOM stands for Document Object Model. And before we actually get into how this code works, let's look at what this code does. In DOM0.html is quite simply this form. I'm going to go ahead and click Submit. Oops, no. I'm going to go ahead and type in, say, my name, and click Submit. And oh my God, it says, hello, David. Like, that's amazing. It's dynamic. It literally said what I typed in. Well, OK, maybe David wrote the page, so maybe this isn't all that compelling. So let's try another. Let me go ahead here and type in, say, a colleague like Zamila's name, submit. Oh my God, it supports Zamila as well. Now, maybe I wrote the web page and just I added support for David and Zamila, but no, this is actually a generalized solution to the problem whereby, much like I could do in Scratch or C or Python or other languages, this web page is getting user input and then producing output on the screen dynamically. It's a little cryptic insofar as it displays in this ugly pop-up on the screen. And frankly, the browser is asking me if it wants me to prevent this page from creating additional dialogues, because you might remember the yesteryear where the pop-up windows were all the rage on the internet. And indeed, browsers have gotten smarter about blocking those and actually asking you, hey, wait a minute, this page is putting up a number of prompts, 2 in this case. Are you sure you want to let it keep doing this? But that's just a feature of the browser. And that window will look different in Firefox and Chrome and Edge and Safari and other browsers still. But how does this work? This is just an input, and this is just an input. And previously, these inputs whisked me away to google.com, where I saw a whole bunch of dogs as search results. But now, I'm not going to Google. I'm certainly not seeing any cats or dogs. I'm instead seeing David's name and Zamila's name and anyone else's name that I type in. So how is that working? How is somehow the web page grabbing the data that I've typed in and doing something with it? Well, it's doing this by way of, yes, some HTML in the page, but also now some JavaScript. And to get to this point, let's introduce the following. This is the Document Object Model, or DOM, which is just a fancy way of saying this is the family tree-like structure that you can think of as being underneath the hood of any web page. There has been since the start of our examples, an implied hierarchy to all of our web pages. Besides the doc type declaration up top, there's been this so-called root element, HTML, inside of which there's always been two children, head and body, inside of which there were 0 or more other children, like title. And the indentation and the nesting implies that there is some kind of hierarchy. It kind of reads from left to right, but really, if you flip that around 90 degrees, and again, think of HTML as the head, all of these other tags are kind of conceptually below it, a la a family tree. And indeed, if you think of this being the document itself, like the file, the root element of which is HTML, this thing here, HTML, again, has two children, so we can kind of dangle those off like you would a family tree, two descendants, head and body. Body, meanwhile, just has some text, hello world, and I've drawn it or circled it with an ellipse here just to kind of convey that this content is not like this. These rectangles are elements, open and close tags. This is just text at the very leaves of this tree. Meanwhile, head does have another child, title, as per the rectangle, and then it too just has some raw text, like hello world. So you can think of that as to say, a web page as, yes, being hierarchical, but also as being a tree. And if you recall, among the data structures in a computer scientist toolkit is this thing called a tree that can look quite like this. And there might be more than this many children. It might have more than two children still. But there's this way of representing in a computer's memory, or RAM, exactly what's being sent to the browser over the internet as just text. So upon receiving an HTML file, when I say a browser is reading it top to bottom, left to right, that is true, but it is also building up in its own memory a data structure that looks quite like this in RAM, in memory, so that the browser can kind of navigate that web page as needed. Now, why might it need to navigate the web page? Well, once you introduce JavaScript, does it become really compelling to be able to look at not just the raw text, but the individual nodes, so to speak, the rectangles and ellipses in the tree. But we need to introduce this tag here, the script tag, where we can put our JavaScript code in the head of our web page here, but we'll see this can go in different places. Here, then, is dom0.html. At the very top of the body, notice is a tag we've seen once before, form. But notice it's got a new attribute we've not seen, onSubmit. And you can kind of guess what this means. OnSubmit, do the following. But what's the following? Well, notice that inside of quotes here is some funky looking syntax. And if you've programmed before, you might recognize these as being a function call and then a return statement. But what does that mean? Greet, it turns out, is a function, an action, a verb. It's a puzzle piece. Like say, for instance, in the world of Scratch. And return false just means don't do your default behavior. So jumping the gun, what is the default behavior for a form on the internet, even as we've seen it before and as you've certainly used it before? Well, it's to submit whatever you've typed in to the server. You're registering for a website, you click submit, goes to the server. You're logging into a website, you click submit, should go to the server. You're searching for dogs on the internet, you click submit, should go to a server. By saying return false here, this means don't send anything to the server. Keep the user locally to our HTML page. And that's the goal of this particular demonstration. So what are the inputs for this form? Well, one is called name, and one is and its type is text, and the other is of type submit. And I've added another attribute here just to make things prettier called placeholder. And this is how you get some gray, literally, placeholder text that the user sees, kind of as instructions. Now, what is greet and what is going on here? Well, let me scroll up to the top. But before I do, realize that per this attribute onSubmit, when this form is submitted, the greet function should be called. The greet action should be taken. The greet puzzle piece, if you will, should be executed. So what is the greet action? This is a function that does not come with JavaScript, doesn't come with browsers. I invented it up here inside of this open and close script tag. Notice that per the purple word, function, greet is indeed a function. And now I'm using this built-in other function called alert. This does come with JavaScript. This does come with my browser. It doesn't create very pretty alerts. It's what creates that ugly dialog window we saw a bit ago. But when I say alert, notice this cryptic looking string of code. And for today's purposes, it suffices to know the following. So quote unquote hello comma space is going to print exactly that on the screen. So quote unquote and whatever's inside is going to get displayed on the screen. The plus is a little funky here. It's not for arithmetic or addition. It is for concatenation. This is telling the browser, hey browser, print out the word hello comma space and then append to it, concatenate onto it the following. And this one's a little more cryptic. Document.getElementById, quote unquote name dot value. It's kind of a mouthful, but let's think about what's going on here. Document is a special object, a special variable, a global variable, if you will, inside of which is a whole bunch of functionality that comes for free with your browser. Some of that functionality, another action, is called getElementById. Well, what does that mean? Element, we've heard this term before. It refers to an HTML tag, or really the open and the close tag and everything inside of it. Name is in quotes here, so that probably has some special meaning. More on that in a moment. And then dot value is probably the value of that element, whatever that means. So what is name? Well, let me scroll back down lower in the file and notice what's going on down here. I took care earlier when defining this input to give it not just a type and a placeholder, but a unique identifier called name. Could have called this anything, foobar baz, XYZ, but again, none of those are very descriptive, so I called it name. And this is important because I knew preemptively I want to be able to get at that element directly, and I don't want to confuse it with any other, so I want that identifier to be unique, and I want to be able to get its value being whatever the human typed into that input box. And so, because I have ID equals name here, and because I'm saying, hey browser, get the element whose ID is name, and then hey browser, go get its value, this is the way that my browser is dynamically going into the DOM, the document, that tree structure, finding the element in that DOM whose ID is name, and then looking inside, hey browser, what did the user type in? And so what comes back is DAVID or ZAMYLA or whatever the human has typed in, and that gets, again, concatenated on to the end of this partial phrase. What gets concatenated on to the end? Well, here's another plus. Here's a quote-unquote exclamation point. So this was just my way of making the alert friendly. Hello, David. Hello, Zamila. We have three separate substrings or phrases being concatenated together. So hello, comma, space, whatever the user's name is, and then that exclamation point. And then some of this other stuff like the parentheses and the semicolon, these are just features of the language itself, JavaScript. This is some of the syntax that Scratch, for instance, does not have, but some languages like C and Python and C++ and Java do have some other syntax like this that is sometimes necessary. But for now, let's focus really on one of the most fundamental ideas, which is a browser's programmatic ability to do something via programming, to get at data inside of a web page. And it's doing that not by searching the web page's HTML, because again, the HTML that comes from server to browser is this. There is no mention of David, there is no mention of Zamila inside of this file. That is dynamically provided by the human user once this web page has been rendered. And DAVID and ZAMYLA is this text that ends up being stored in the tree structure, the DOM structure, that code like this in a language called JavaScript allows us to access on demand. Okay. Now, much like we improved iteratively the design of our CSS, let's similarly do a bit of that refinement using JavaScript as well. Let me open up dom1.html and propose a somewhat different solution to the same problem. Notice in this example, I again have the form element as before, But I've also added one other unique identifier. And again, there's different ways I can do this. I have chosen to use IDs, but 2 this time, whereby I've given my form a unique identifier. Again, could call this ID XYZ, foobar, baz, anything I want. I only have one form in the page, so I decided to keep things simple, and I just uniquely identified the form as form. But even that isn't all that compelling, but it's at least specific. So now if I scroll down to the script element, notice that this time the script tag is below the form. It's not in the head. It's actually in the body, toward the very end of my body, below the form itself. And notice somewhat new syntax here. So this line here, you can perhaps reason through what it's doing, although it's a little bit of a different approach. Document.getElementById, quote unquote, form. So as before, this just means, hey, browser, give me the HTML element whose unique identifier is form. So that refers, of course, to the one form. And then this is a new property. Before we used value. Now I'm using onSubmit. So it turns out that there is a property in the world of JavaScript associated with an HTML form that you can access by way of this syntax. So this is a way now of saying, hey, browser, associate with the onSubmission of this form the following function. And again, a function is just a puzzle piece that is a call to action. It's just a verb. It's a set of instructions that you want to be executed. This function doesn't happen to have a name, but that's fine. The curly brace here and the curly brace here just mean this function is 2 lines long. What does this function do? Does the exact same thing. Notice this alert line is exactly the same, and notice that I'm returning false down below here, so as to short circuit the submission of any data to a server. I'm handling all of this inside of my current web page. So what have I done that's different now? Well, notice, just like I iteratively improved my CSS, and I removed from my HTML any mention of CSS properties, which again just felt like it was getting messy to like commingle these multiple languages, so have I, with this example, taken a step of removing from my HTML any mention of onSubmit, relegating this other language, JavaScript this time, to be inside of its own tag. Previously, it was the style tag for CSS. Now it's the script tag for JavaScript. But I've taken a step toward separating my data from my presentation and now from my logic or business logic, my programming code. And I've specifically, as an aside, put the script tag below my form tag because it turns out browsers, as fancy as they might seem, are pretty dumb in that they only do what they're told, and they only do it in the order in which they're told, top to bottom, left to right. And so if I were to try to call this code whereby I'm associating this function with the submission of this form, if I tried to put this code up here, it wouldn't work because the form doesn't exist yet. Only once the browser has read from the top through this portion of the file does that form exist in its memory, in the DOM, the data structure, the tree that it's building up, at which point it then makes sense to associate this JavaScript function, this event handler, so to speak, with that particular element. So this was deliberate, but again, that's a finer detail than is fundamentally necessary to perhaps follow along here. But let's do one further step. In dom2.html, sorry, let me do one change. Source dom2.js. Okay. But we can do one further refinement here. Just as with CSS, we can completely separate our presentation from our data. So can we completely separate our logic from our data by simply relegating the contents of this script tag, essentially, to another file. And indeed, in dom2.html, sorry, let me do that part again. But just as we did with CSS, whereby we completely separated our presentation from our data by moving our CSS to a secondary .css file, so can we leverage that same principle here and completely separate the logic of our code from the data that it is accessing by relegating the contents of this script tag, essentially, to another file, something ending in .js for JavaScript by convention. And indeed, in dom2.html, do we have a file that does exactly that by moving to the head of the page, in this case, the script tag, dom2.js, inside of which is not only those lines, but a couple of others that ensure that even though this script tag is in the head of my web page right now, it is ultimately going to be executed later, once the whole DOM has been rendered. Alternatively, we could also move this script tag to the bottom of the page still. OK. All right. But this is not a particularly common case. To visit a web page that asks you to type in your name, and then it just says, hello, David, or whatever your name happens to be. I mean, typically, when we have seen programming code being used in a browser, it's for pretty fancy features, like actually checking that I've typed in all of the fields to a form when registering for a website, or making sure when I am registering for a website that maybe both of my passwords actually match, and yet other applications still with JavaScript. So let's take a look at a few other examples, these involving actual forms that are meant to be submitted. For instance, here is form0.html. In this case, notice that I have an HTML form that doesn't have an action or a method, because I actually, for demonstration purposes, don't really want this to be sent anywhere. In fact, there's nowhere to actually send it, because I don't have the back end of a database to store this information. All we care about is this front end. And notice I'm asking for a few things: the email of the user, their password again, and then I want them to agree to some terms and conditions. And so we'll see a few new features here of HTML forms. Not only do we have a text box, as we've seen before, for their email address. Turns out there's also type equals password. That's still just a text box. But if you've ever noticed why password boxes have like bullets or ... instead of seeing your actual password, just for privacy's sake, this is how that actually happens. This one, too, for the confirmation, is also of type password. But notice I've given it a different name. The name of the first field is email, second is password, third is confirmation, but I could have called it password2 or something else. And then lastly, I agree to the terms and conditions. Notice is of type checkbox, so that it's something the user can click on and off. And I'm just calling that arbitrarily, but reasonably agreement. And then lastly, I have a submit button whose value or label is register. And then this is very simplistic formatting. I'm just using line breaks. BR is the line break element. So it doesn't give me a full-fledged paragraph as would be appropriate for sentences of text. It just makes sure that each of these things ends up on a new line, the line therefore being broken with BR. All right. So what opportunities are there for validation, so to speak? Form validation being the buzzword here. And what mistakes, in other words, might a user make? Well, they might not type in one of these fields, and I want them to do something with all four of these. So I could check, did the user fill out the whole form? The user might type their name or an invalid email address because of some typographical error. They forgot the @ sign, or they misread what they're supposed to type. So maybe there's an error there. Password, maybe it's too short. Maybe it doesn't have enough letters or numbers or punctuation or all those annoying things that websites typically impose for security's sake. Maybe they typed the password fine the first time, but they made a typo the second time, so they don't match. And the website wants to make sure when you're registering that you remember what your password is. And if you typed it two different ways, unclear which one should be your actual password. So we might want to check for that. And then, of course, because of our lawyers or whatever, we want to make sure that the user checks that checkbox. And so we want to make sure that the human took that deliberate action of making an unchecked box checked before they click register. So a bunch of juicy opportunities to actually validate the user's input. There are no validations in this file. There is no JavaScript in this file. This is just HTML. So if I clicked register, the submit button on this page, what I typed or what I didn't type would get sent to the server, blank or not. So I want to add some logic to this. And I want to see how you might go about implementing this kind of logic. So let's look at form 1, which is a addition to this file of the following lines. Again, the particulars here won't necessarily matter in great detail. Take away from this the overarching principles that we're now applying via this intersection of JavaScript code and a web page's DOM, or document object model, its tree. First line of code in my script tag here is to get from the document the element whose ID is form, just as before, and it refers to the one and only form in the page. Then I'm doing form.onSubmit. So this is a little more succinct than last time, but you can infer from this, well, if you have a variable, as in algebra, x, y, or z, but in this case it's called form, and I'm associating with its onSubmit listener, we'll call it, the following function, this is just a very succinct way in JavaScript of saying, hey, browser, when that form is submitted, execute the following lines of code, the function. And there's a bunch of lines. It's not just 2 this time. It's like a dozen or more. So what are these lines doing? Well, here, you'll find that each of these chunks of code follow a pretty similar structure. If the form's email field's value equals quote unquote, so nothing. If the user typed in nothing, alert the user, you must provide your email address. And then return false to make sure that the form does not get submitted. Now there's some weirdness here. 1, parentheses. 2, double equal sign, not a typo. Long story short, in many programming languages, equal actually means copy a value from one side of the expression to another. Equals equals means check for equality. So it just turns out that the same symbol is kind of used for 2 different things. So they separated them semantically with double in this case. So that's how we check that the user actually typed in his or her email address. What if we scroll down here? Same kind of validation, but for a different field. If the password's value is blank, yell at the user, you must provide a password. If the password's value does not equal the confirmation's value, so if those 2 password-related text boxes are not the same, an exclamation point equal sign, it means not equal. So there isn't really a way on your keyboard easily to type the equal sign with the slash through it. So what most programming languages do is an exclamation point, which typically means not, or invert, equal sign. So does not equal this. So if the password does not equal the confirmation thereof, yell at the user, passwords do not match, and then return false. And then down here, lastly, this one's too is a little cryptic, but it gives you a taste for what's possible. If it is not the case, per the exclamation point, that the form's agreement checkbox is checked, which is kind of a Boolean expression, if you will, as per our time with Scratch. If it is not checked, then yell at the user, you must agree to the terms and conditions. And so this represents the checking that the user has actually checked that box. So there's any number of other things we can do, and there's any number of ways we could implement this same kind of code. Indeed, we could use libraries, code that other people have written to make this much easier so we don't have to implement all of this ourselves. And it turns out we're still going to have to, and we're still going to want to implement these same kind of checks on the server just in case a user slips by and maybe their browser doesn't have JavaScript enabled or something. We're still going to want to validate all of this data server side. But for the most dynamic, immediate experience, checking things in the client using JavaScript code allows the user to get an instant feedback before he or she even clicks the submit button and sends the data to the server, which especially on a mobile device can take some time. It's not nearly as immediate as actually running some programming code in the browser. But if all of these tests pass, notice how this last line is returned true, which means, hey, browser, submit the form to the server. And again, I didn't configure this example with an actual server, so it's still not going to go anywhere. But it would if we actually added an action attribute and a method attribute to the form as a result of this return true. So what's the takeaway here? With HTML, do we have the ability to mark up a web page, format our data, and generally provide the user with a fairly simple experience? Oh, sorry. Do we want to say that? Let me rewind, sorry. Go ahead. Now, as was the case with CSS, when we could factor out our CSS to a separate, yep, okay. Now, as was the case with our CSS, where we were able to factor out from our .html file our CSS code into another file, so can we do the same with our JavaScript code, relegating it to a script tag with a source attribute so that my lines of code are actually in, for instance, oh, we already did that, sorry. Oh, do I want to do that? Okay. Okay. Now, of course, this might all look pretty cryptic. We've dived in pretty deep quickly to not only HTML and CSS, but now we're using a third language to actually manipulate that whole world. But realize that JavaScript, though the syntax of it might be a bit cryptic at first glance, and while some of this might not have gone down so easily, realize that the ideas that are possible within this world of JavaScript, in this domain of web pages, is really not all that different from Scratch. For instance, just to bridge those two worlds, recall that in Scratch you might have had this adorable purple puzzle piece via which you could say hello world. So, oops. Sorry, let me just change these for consistency. For instance, recall that in Scratch we had this adorable purple puzzle piece via which you could say quite simply, hello world. Well, in JavaScript, as we've seen, you can still say the same, but it's a little more cryptic. The syntax is, of course, textual and not graphical. But at the end of the day, the functionality is essentially the same. Alert, open parenthesis, quote unquote, hello world, close parenthesis, semicolon. So again, there's absolutely some syntactic overhead there. There's definitely some complexity textually, but the idea is exactly the same. Recall, too, that in Scratch, if you wanted to do something forever, you might pull out the forever puzzle piece, inside of which might be one or more blocks that you want to execute forever. Well, in JavaScript, we can implement this same idea using this block of code, while true, alert, hello world. Different ways to do this, and indeed alert is really just for the context of a browser. There's other ways to do this in, say, the context of a terminal window or a black and white prompt. But in this case, is this the JavaScript way of saying to do something forever? If you don't want to do something forever but a finite number of times, like 10, we could say hello world in this case 10 times using a for loop. Something's wrong here. Sorry. If you instead want to do something not forever, but a finite number of times, like 10, you can translate the Scratch blocks above to the JavaScript code below using keywords like var and more semicolons and a less than sign and the like. But this is a so-called for loop as opposed to with the earlier while loop in JavaScript. So syntactically more involved, but fundamentally the same idea. Meanwhile, if in Scratch you wanted to assign a variable like counter, initially the value 0, and then forever just print it and then increment it by 1, in JavaScript at write you could do the same with a bit new syntax, combining some of these same ideas. And then if you wanted to do something conditionally in Scratch, you might borrow an if-else block and then another if-else block so as to nest them inside of each other to create a three-way fork in the road. And you can do the same in JavaScript using some code like that at right there. Now, we have only scratched the surface here of JavaScript 2. But much like some of our takeaways thus far have been with HTML, can we mark up a document on our data for presentation? With CSS, can we stylize that presentation, getting the colors and the font size and the thickness and the positioning just the way we want it, just right? So with JavaScript, can we do all that and more? Because with JavaScript, do we have programmatic access to the DOM, the document object model, the data structure, the tree that represents that web page in memory. And though we have just used JavaScript here for some relatively simple examples whereby we grabbed values from the DOM and we checked those values for in order to validate them, so could we actually dynamically change the color of a web page or the positioning of something on a web page or even add new content to a web page. Indeed, by way of JavaScript, are there technologies like Ajax, which allows you, with JavaScript, to make HTTP requests on the internet for more data so that you can then embed more data on your web page. For instance, if you've ever used Facebook Messenger and you're noticing that you get a chat message and another chat message and another chat message from one or more friends, you're still staying on the same web page. You don't have to reload the page in order to see your new messages. They just dynamically appear. That is because Facebook is using JavaScript that's constantly running, as in a forever loop, and it's constantly asking the server, does David have more messages? Does David have more messages? And if so, it injects them dynamically onto the page by manipulating the DOM for Facebook's own site. Similarly, if you're a Google Chats user or Google Hangouts and you're getting dynamic output that way, similarly is JavaScript creating that dynamic experience. If you use Google Maps or Bing Maps or any number of mapping tools whereby you initially see maybe your location in the world, but you can click and drag and search for other places around the globe and then immediately see tiles or map pictures of where those places are in the world, that is thanks to JavaScript. Because as in the case of searching and validating a form, so are all of those map-based websites listening for your textual input, and as soon as you hit enter, searching their database for the result, and then updating the contents of the page in real time, sometimes with the fanciest of animations, which are also the result of JavaScript and perhaps some CSS. So it's with these trio of languages, HTML and JavaScript and CSS, ultimately, that you can create some wonderfully immersive user experiences and wonderfully immersive user interfaces. But we haven't necessarily considered with too much detail what kinds of devices users are using. We did give some thought to friendliness on mobile devices, at least so far as it goes with font sizing. But we haven't really given any thought to offline access to data, if that's indeed something we want to support. We haven't yet given some thought to the scalability of our websites and our code, so that if we have not just one user like me here, but 1,000 users or 10,000 users or 1,000,000 users, what are the implications for my server? What are the implications for my code? If my code's just a little bit slow, does it now begin to feel slow for all of my users and in turn all of my customers? So now that we have the ability to put code on the internet and the ability to put web pages on the internet, now we're going to have to start to give some thought as to how to put them on the internet well and in a scalable way, in a redundant way, in an available way. But for that, we need a new, damn it, I was paving that road as I went there. Shit, how to fix this? Buffer that. OK, maybe we can fix this with a close-up. But for that, Yeah. Like this? Okay. Okay. But for that, we need to dive deeper into the cloud and understand exactly what cloud computing is. Yep. Sorry, I just couldn't get the words out right. Same flow? Okay. But for that, we need to dive in all the deeper into the so-called cloud and explore what cloud computing itself is.
Can you do one more and this time finish but for that before you turn? Before you did that before.
So say, but for that? Okay. Okay. I'm going to shorten it too. But for that, oh, right. But for that, we need to spend all the more time in the cloud. Okay, one more time, if that's okay. The cloud. But for that, we'll need to understand first, all the more, the cloud. Okay, that was good. Nope. Yes, okay, so David ran out of words toward the end there. I really just wanted to end on an eloquent note about cloud computing as kind of a setup for what is coming next. Is that what's coming next? Wait, we have one other thing too. Oh, technology stacks. Oh, that's the, no, okay, new ending, if that's okay. Sorry, I'm glad. Okay, don't use any of the previous couple minutes, but for that, okay, but for that, we first have to make so many, we have a number of other choices. But for that, what was the that in that sentence? Now I'm drifting. And what was the for that? What was I referring to? Was it like all the choices? Sort of related.
Other things you can do with JavaScript.
Oh, okay. Okay, yes. Okay. What's that? Yes, okay, but for that. Okay, here we go. Whew. So close. Okay. But for that, we first need to make a number of other decisions first. We need to decide what languages to use on the back end, what libraries, what frameworks to use on the back end, and then how to host all of this code out there. And for, okay, that's good. I like that. Technology stack. Okay. Ready? But for that, we first need to make a number of other decisions around what languages to use on the server, and what frameworks, and what libraries, and what more to use in order to support this front-end user interface. Because indeed, we have at our disposal so many, okay, now I'm thinking too much. Okay, ready? Last one. Ignore all that. But for that. But for that, we first need to make a number of choices around the languages we use on the server, the frameworks or libraries that we use, and indeed, what technology stacks we deploy. You'll take that? Okay. So the first time I said, but for that, keep that. Delete everything we shot after that until that last take. The URL. Oh, yeah. So oh, yeah, you want to do it now. OK, yes. So edits to what we've just done to recap is that last segment there. So when I first say, but for that, keep that, cut out all of the bad takes, and then keep just that final take. If we rewind to the beginning of the lecture, at one point, I full screened the browser, or I unfull screened the browser to reveal the URL bar. Let's just mask out the URL, because that's always going to change, and it's not going to lead to any useful destination, keeping the Chrome, but just whiting out the URL. I think once or twice when I saved the file, I futzed with the save dialog, so the user might see me mistyping. But I think if we just do ideally don't show me deleting things, but I think that only happened twice when I opened the save dialog. And is there anything else? I don't remember what that was. What's that? Oh, and at one point I'm being told that the Mac OS dock bar came up, toolbar, so we should get rid of that. Are we still rolling? Can I do one last thing? OK, can we do one last? OK. Yeah, I don't know if it's the Wi-Fi or the server or what. What? Oh, sorry. Yeah, so the server seemed to be giving us the spinning icon a few times because of Wi-Fi or whatever. If we can just cut that out so that the transitions to the code just happen faster. OK, last pickup. I want to change one word. But for that. OK, this is my new obsession. OK, last time. Ready? But for that, we're first going to have to make a number of decisions on the server. What language to use there, what frameworks or what libraries to use there, and indeed, what technology stack to use. OK, that's what I wanted. Whew. All right, for those of you who are tuning in online, we're going to kill the audio for just a bit. We're going to put up some text saying we'll be right back, or are we just killing the stream? OK, so we're going to just kill the audio for some time. We're going to set up for our next shoot. Feel free to tune in, but you won't see anything interesting happen for the next while. See you in a bit. Hello, Internet. So we are back here with the fifth shoot for CS50 for MBAs. I'm here with CS50's own Scully. Who you'll hear more from later, perhaps. So we are about to dive into the topic of technology stacks, which is something we don't really look at in CS50 itself at the college, rather taking a top-level, top-down view of the state of the world in terms of languages and frameworks and libraries and so forth, trying to give our MBA students especially a sense of what the various ingredients are that they can bring to bear when solving a problem, or at least familiarize themselves with some of the technical jargon, the vocabulary, and the products that are out there that their engineering teams might actually be incorporating into implementations. Without further ado, this is scene 5, shot 1, take 1. Who's the director? Okay.
And check.
Hey, Scully,
Yep.
can you turn down David's sensitivity a couple clicks?
Yes. This one was for
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
the better Dan.
This is a test of the CS50 audio system. This is lecture 5 for CS50 for MBAs. I'm here on stage with CS50's own Lawrence.
You better?
Okay, thank you. Damn. Yes, sir.
When you're ready, you're going to start next to the monitor looking at Ian, and you're going to turn back to 1 after you start.
10-4. Oh, yeah, we should get going. Hard stop at 3, yes? Okay. 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 So much as you might understand how the internet works, whether it's HTTP that transports data or HTML that is that data, and as much as you might understand some of the fundamentals of programming like loops and conditions and Boolean expressions, variables, and more, it turns out there are so many different ways in which you can implement those ideas. And so indeed, when it comes time to actually build a website, a web application, a mobile application, it turns out that it's rather non-obvious where to begin sometimes, if only because you have so many options ahead of you. And much like the world of clothing and the world of fashion more generally is constantly evolving, such that what is cool and appropriate to use now or to wear now might not necessarily be appropriate some months or years hence. The same can be said, for better or for worse, of the technology world insofar as humans are constantly innovating. Humans are constantly finding fault or opportunities for improvement in languages that we've used for years, in server software that we've used for years, and iteratively improving on it. And so the reality is that staying current with this whole world takes some effort, even as the fundamentals largely remain constant. And so what we'll try to do here is give you a sense of some of the languages, some of the frameworks, some of the libraries, some of the overarching design decisions that are both in vogue and both here to stay right now, as well as take the lid off of some of these technologies and give you a better understanding of how some of the fundamental types of technologies from which you can choose actually work. So let's consider for the moment, the so-called front end of an application. Front end generally refers to that which is facing the user, so it's the user interface and more with which the human user typically interacts. Now, we've discussed, for instance, the world of the web and how you might assemble a web-based experience using HTML and CSS, and even more dynamically, using JavaScript. But that's by using those native languages, right as they come out of the box, so to speak. But it turns out that some tasks are not as easily done in those various languages as might be convenient. It turns out that there are certain design patterns, so to speak, types of code, types of markup, types of properties that people have found themselves using again and again and again. And so much like you can factor out into your own CSS files and JavaScript files code that you want to share across multiple files or even across multiple projects, so has the world more generally realized, you know what? Maybe I should package up my CSS or my JavaScript in such a way that other people can actually use it as well. And thus have been born things called libraries, collections of code that other people have written that we can all use, often under an open source license, which means the code is freely available for the world to critique, to use, to adapt sometimes, and contribute back to. Now, within the world of the front end, there are so many different JavaScript frameworks. Indeed, depicted here are just a few of perhaps the most popular right now. But even this list is going to grow stale over the coming months, certainly over the coming years and the like. And so really, rather than dive into the weeds of some of these technologies in particular, we really aspire to give you just a sense of what's current, what should be in your vocabulary perhaps now, and perhaps some context when it comes to recruiting engineers or deciding among engineers which technologies to sort of build a business on, just how current you are, just how dated you are, and the like. But invariably, this kind of thing requires some due diligence when the time comes to design an actual project. Angular, Ember, Meteor, React, Vue, these and more are the names for various JavaScript frameworks. And a framework is not just a library per se. A framework is also typically a way of doing things. So a framework includes some code that you should integrate into your own projects, whether it's CSS, JavaScript, or something more. But it also includes typically a way of doing things, a way of naming your own files, a way of formatting your files, a way of building, ultimately, your application. And reasonable people, of course, will disagree. And so you'll find among several of these frameworks different design paradigms, different design beliefs, the best way as to do things. And again, different reasonable people will disagree. And so part of the process of choosing these frameworks really boils down to what resonates most with you or with the engineers with whom you're working. And indeed, what resonates above all else, perhaps, is what one is most familiar with. In fact, it's often the case that you or engineers you're working with simply have done a previous project in one of these frameworks, but not the others. And so even if that framework is for some definition of inferior, that might not necessarily be an overriding concern if you can actually build your MVP or your prototype faster with that particular framework because you know it already than if you could build it a little bit better, quote unquote, and in quotes insofar as reasonable people can disagree as to what's inferior or superior in this world, than if you were to design it using a completely new framework for which there's just a non-trivial learning curve for you. And so there's, as in the case of data structures, as in the case of algorithms, as in the case of computer science more generally, there's these trade-offs. And human time, developer time, learning time is certainly one of the resources that you have to decide how much of which you want to spend up front. Meanwhile, in the world of CSS, there are also libraries there, collections of CSS files, and frameworks, really, methodologies for which you via which you lay out your site, like Bootstrap, Foundation, Semantic UI, and more. And these focus more so on the aesthetics of a user's experience, more so on the presentation of information and the types of user interface mechanisms, the buttons, the menus, the windows, and the like that a user might see on the screen. But here, too, there are so many different wheels that have been invented in the past. So many different people have decided, you know what, that default link on a web page could look much prettier, or that button on a web page could look much better if you used my design. And so this is what's happened. The world has created and shared with others in the world various files that you, either in the context of JavaScript or in CSS or beyond, can integrate into your own projects. So how to even begin to vet these kinds of things, particularly since in a class like this, we won't go into the weeds of evaluating these, and even then, we might not reach any sort of consensus. So the reality is typically relying on the engineers with whom you're working is first and foremost the place to start. What do people know? What are they comfortable with? What did they like? What did they dislike about some framework? Did it actually speed up the work? Did it slow down the work? Did it build up technical debt for them, so to speak. For instance, just because something is easy and quick to get started with from the get-go, is it so easy because it's riddled with poor design decisions such that as you get more and more users, maybe your application or your website's going to be slower and slower, or maybe it's going to become harder to maintain, or it's going to be harder to onboard new people altogether. There's various trade-offs there. And so considering what is optimal now, what is optimal in the medium term, what is optimal in the long term should perhaps be part of that whole conversation. Meanwhile, it's certainly a compelling thing from a professional development perspective for keeping things fresh to actually go and learn something new. And so certainly punctuating one's experience in tech, should there be an opportunity to both pick up some new skills, to familiarize oneself with the latest and greatest, and not necessarily change direction with each and every fad, but generally be familiar with some of the trends in industry. And there's a bunch of ways with which to do that. I mean, one, certainly relying on Google and other search engines just to get a sense of what the most popular hits are, or search results, when you search for something like popular JavaScript framework, or some such search string like that. Looking on websites like Hacker News from Y Combinator, where there's an active community of folks from the startup community, especially talking about these kinds of technical decisions and design decisions more generally. Websites like Quora or other Q&A websites. Looking at github.com, a popular website where people store their code and can actually follow or star other people's repositories of code from which you can infer a sense of popularity based on how many people are following framework X or Y or Z. But this is always a moving target. And so it's simply part of the conversation to have from the get-go. And you're not necessarily going to regret a decision if you don't necessarily pick the most trendy or the one that's poised to take over all others. And because this is a fast-changing world. And in fact, one of the most frustrating, if not expensive, aspects of this world is just how quickly it changes. And so what you design today might not be what you design tomorrow, but that's also part of the excitement of this space. So with that said, that's just a glance at what the front-end design process or decision process might be like. Let's take a look now at the back end, at least in the context of languages. So here you have even a longer list, because at least in the front-end world, recall that the de facto standard is to use JavaScript in the user-facing web browser experience. But on the back end, on the servers from which the HTML and the CSS and even the JavaScript are ultimately coming, you have so many more design decisions. So you have languages like Go and Java, JavaScript, .NET, PHP, Python, Ruby, Scala, and so many others. These are perhaps just a few of the most popular these days. And all of them have their pluses and minuses. All of them have their supporters and the detractors. And all of them have folks who already know them or who might have to learn them among engineers with whom you might work. Meanwhile, though, those languages, out of the box, so to speak, don't necessarily make designing a web-based application easy, or as easy as it could be. They don't necessarily make building a mobile application as easy as it could be. Or even if it is relatively easy, humans have found over time that, gosh, every time I build a mobile application, I'm like copying and pasting dozens or hundreds of lines of code because they all share a common framework or maybe a common menuing system or a common set of functionality. And so in this world, too, have libraries of reusable code built up and frameworks, libraries of code and methodologies via which you're building your applications arisen. Among them, Django, Flask, Laravel, .NET, Node.js, Rails, and the like, .NET being up there too, because it generally refers to a set of languages you might use as well as the framework that oversees those various languages. And there's even more options ahead of you here. So how do you begin to pick among these options as well? Well, here too, you're often guided by what your engineering team knows, perhaps what your own system administrators or your operational people know. So the folks who are actually maintaining the servers, whether they're locally on site, maybe they are the ones running things in the cloud, whether that's Amazon's or Google's or Microsoft's cloud or some other company still, depending on what that cloud infrastructure supports, might influence your decision making as to what language you might use. Sometimes the nature of your application might influence the language you might use. For instance, some of these languages make it a little bit easier to make real-time applications. Applications that support like chat servers or immediate interactivity where there's a constant connection or the illusion of a constant connection between browser and server. PHP doesn't really make that all that easy. You can do it, but it wasn't really designed with that use case in mind. By contrast, JavaScript via a framework called Node.js makes that really easy to do. And it was designed more so with that kind of use case in mind. And so here, too, you see hints of why some of these languages and in terms frameworks have arisen, because they are actual solutions to concrete problems people have experienced in the past. And some of these languages are newer than others, and so they might come with more features, so you don't have to rely as much on third-party libraries. Some of them less vetted, or maybe less robust, or even less secure than what comes with the language itself. And recall, too, that these languages are often constantly evolving, some more quickly than others, but there are new versions of these languages coming out. And so even within the confines of a given language like Java, might there be new and improved features every year, every couple of years. And so sometimes actually picking a version of these languages or frameworks is one of the design decisions to bear. And I would say from a non-technical perspective, most compelling is just to be aware of these kinds of technologies, these kinds of buzzwords du jour, but also aware of these kinds of trade-offs. It's not necessary to get into the weeds, I think, of understanding each and every language and what it's good for, although once you have a general understanding of this world of programming, of server-side architecture, of HTTP and web pages and the like, can you, via Google and other websites, I think start to wrap your mind around some of the trade-offs and perhaps even start to tease apart which are technically compelling arguments that you might see online versus just religious objections to this language or that, because that's often the case when folks get into heated discussions of language choices, for instance. But I think ultimately understanding the trade-offs, the onboarding time or the learning curve for various languages, the appropriateness of language for certain specific use cases like the real-time chat applications or whatever your own product happens to be. What your engineers already know, what they're good at, what they prefer to use, what language and framework is easiest for new hires, maybe 6 months hence or 2 years hence, to actually come on board and understand, so that you're not expecting the most experienced of new hires to constantly be in your pipeline. So appreciating these kinds of trade-offs and asking these kinds of questions, even among the engineers that are perhaps making the decision ultimately, is a valuable way to contribute to the conversation and take some comfort in the fact that your product need not be a complete black box. You might not necessarily be able to implement it from scratch yourself, but you can at least ask the right questions and be a sounding board for some of the answers that come back. Now, there are some fundamental differences in some of these architectural decisions, among which are around choice of database. Indeed, most any web application today has a back-end database inside of which is stored data from users, whether it's purchase orders or user registrations and passwords, and any amount of data that's collected from users at the end of the day is stored somewhere, and that somewhere is called a database. But there's different types of databases. Two of the biggest categories these days are perhaps SQL and the opposite, NoSQL, as it's playfully called. SQL being structured query language, and NoSQL referring to a class of databases that doesn't support SQL and indeed is not generally relational. And we'll soon see what that means. But even with this world, you have a veritable menu of options: MariaDB, MySQL, Oracle, Postgres, SQL Server. And then within those, within that relational world, you also have the in addition to that relational world, you have the contrast of the object-oriented or document store world, things like Bigtable, Cassandra, HBase, MongoDB, and others. And already it can be sort of overwhelming to feel like just as you're getting up to speed on like what the web is and how web pages work, oh my God, like we're just beginning to make our decisions. But generally, these decisions, too, can be guided by what your team knows, what you're comfortable with, what the price might be for some of these. And some of these are free and open source. Some of them have commercial licenses associated with them. Some of them are supported easily for you with your cloud provider, wherever you're hosting your servers, or you might have to host them yourself. So you can begin to narrow the field of options. And indeed, especially when building multiple products, might you build on past experience of yourself. So for instance, for the course and all of our web-based applications, we tend to use a lot of the same technologies. And only recently have we begun to transition from one main language to another, but doing it pretty much for all of our applications across the board so that we don't have to worry about some of the team members knowing X and Y and Z. It's just there's an economy to scale to focusing on relatively fewer technologies internally. But let's dive in a little deeper into SQL and NoSQL, if only because they're so cleanly bucketized into SQL and not SQL, really. What do we mean by this, and what does a database really do? So a database typically supports at least these four operations, or categories of operations, playfully called CRUD, which stands for create, read, update, and delete, though you might see some variations on what the actual words are. But CRUD refers to those four fundamental operations. Now, in the world of SQL, or SQL, structured query language, which itself is a programming language, and it's a programming language you use to query a database, to add data to a database, remove it, edit it, and the like. Within the world of SQL, there is a direct mapping of these four operations to four keywords, four features of the SQL language, namely create, select, update, and delete. So it's almost CRUD, but it doesn't quite line up perfectly. So create, read, update, delete is the general notion of the four operations a database might support. And in the world of SQL, which we're about to dive into, might you see these four commands specifically: create, select, update, and delete. So what does it mean to be a SQL database? Or more generally, what does it mean to be a relational database? Because a relational database is often historically what people think of when they think of databases, and only in recent years has this NoSQL trend been catching up that changes the paradigm. And we'll look at the flip side in just a moment. So if you've ever seen this, whether it's this version of Excel or some equivalent version of Numbers or Google Spreadsheets or the like, this is kind of sort of a relational database. It is a piece of software that allows you to lay out your data in rows and columns. And among those rows and columns are there typically relationships. Consider, after all, the last time you used a spreadsheet, if ever. Odds are there was some kind of meaning if you put data in column A versus B versus C versus D. In other words, when adding data to a spreadsheet, typically, if you're using it correctly, you don't just start plopping your data in any random box that doesn't yet have a number or a word in it. You generally organize the data such that in column A might be one type of data, column B might be another type of data, and so forth. And so it's relational in the sense that the numbers and the data within relate to one another. And it's also relational in the sense that you can have multiple sheets, even within a file. So by default, with Excel and Numbers and Google Sheets, you get just one sheet or worksheet by default. But if you ever want to have multiple types of data, but all in the same file, just because it's kind of nice and orderly to keep it all together, you can click like the plus and create a new sheet and have a completely different tabular structure, a different number of rows and columns and different meanings for those columns, but somehow the data is all related. Ergo, this notion of a relational database. So a relational database stores data in tables, and a table is in turn a set of rows and columns. So why does this actually matter? Well, Excel is not all that powerful when it comes to large data sets. In fact, it wasn't all that long ago that Excel, I believe, only supported as many as 65,536 or 35 rows, probably. And that's because, long story short, they used a 16-bit integer, the biggest number for which is 65,535. And so Excel physically couldn't count as high as 65,536 or 7 or 8 because they just didn't use enough storage underneath the hood. But even if you had that much data, and that's quite a lot of rows, the software just tended to be super slow. At least in my own experience back in the day, trying to manipulate very large data sets in Excel just wasn't designed for tens of thousands of rows. By the time you're at that much data, you should really be graduating, so to speak, to an actual relational database management system, a server-driven database that actually leverages not just files, but memory more effectively. In fact, among the features you get from products like MariaDB and MySQL and Oracle and Postgres and the like is you get really smart people who have implemented the software in such a way that it makes your creates and your reads and your updates and your deletes faster than they might be if you were just storing all of your data in a big file. For instance, in a big file like Excel, if you want to search for some information, you can hit Command F or Control F or whatever, type in a keyword, and then Excel or numbers or sheets will search for it. But generally, these spreadsheet programs are going to search for your data pretty much via brute force. Search top to bottom, left to right, looking in every darn cell for that data. That's fine if you've got a pretty small spreadsheet. We slow humans aren't going to notice the difference. But in the context of really big data sets, tens of thousands of rows, let alone millions or billions, it does not suffice to look at every piece of data when looking for a certain phrase or a certain number or some such value. You want the database itself to do some anticipatory optimization, sort of working its magic underneath the hood using various algorithms and data structures so as to optimize those queries and to give me answers in logarithmic time, not linear time, or time that's faster than searching the whole darn thing. So at some point, spreadsheet software does not cut it, and you transition to a more proper relational database. But moreover, at that point, you have to start deciding how you want the database to store your data. Because at the end of the day, we humans generally know a little more about the programs we write about the data we're going to be storing. And by this I mean, if I am storing a bunch of data in a database, you know, I probably know better than the computer might know which of these values is always going to be like an integer, or which of these is always going to be a dollar amount, or which phrase is always going to look like a time of day, or a date, or day of the week, or some other such value. And so we humans can actually help databases help us be more highly performing by providing them with hints, otherwise known as data types, that tell the database what type of data to store and therefore how to store it most efficiently. Some of those popular data types in the world of SQL then are these. And let's just take a look at a few of these. So char and varchar. So char being shorthand for character. And it's not a single character like A or B or C. Character, or char, generally refers to a column in a database that is going to store one or more characters, a little confusingly. A string, so to speak, where a string is a sequence of 0 or more characters. So when designing a database column that you know is going to contain a word or a sentence, or heck, even a paragraph, you can tell the database, hey, database, make this column this many characters wide, i.e. allocate that much data up front. But if you're not sure, as might often be the case, maybe someone has a short name, maybe someone has a long name, maybe someone has a long address or a short address. If you don't really know what the right length is for a column, for the values a user is going to provide, you can instead use varchar for variable length character strings, which is to say you specify only an upper bound. So I don't know what the longest name is in the whole world, but my name is David. 5 feels like it's kind of short. Probably some people with longer names in the world. 20, is that enough? I don't know. 50, I don't know. 100, probably. I should probably Google to find out with a bit more reassurance. But this is a decision that the web designer or the database designer is going to have to make. You can't just tell, and you don't want to just tell the database, accept any length string. Because the more flexible you expect the database to be, the more generous you expect the database to be, the less optimization it can do for you. By contrast, the more precise you can be, the more conservative you can be, the more optimization, algorithmically, the database can do so that when you ask it for data back, it can give you those answers faster. When you insert data, it can insert it faster. So the more helpful we humans can be with our databases, the more helpful the database can be in turn. And that's probably a good thing when we have lots and lots of data in users, because we want the common case to be highly performing. It might cost me a minute, 5 minutes up front to really noodle on the problem and figure out what the best design is, but that cost is going to be amortized over thousands of users, millions of users, who are then benefiting thereafter from a better database design. So where's the line to be drawn? We'll explore this in the context of an example, but it kind of depends. There is no right answer necessarily. It really depends on your use case and the data you're trying to store. With numbers, too, do you have some discretion? Integer means what it is, generally a 32-bit value, which means you can have a number from -2 billion to +2 billion, give or take. But that might be overkill. If you know you're dealing with really small integers, maybe you don't need 32 bits. Maybe you want fewer, and so you might just say small int, Doesn't need to be that many bits. I know my values aren't going to get that large. I might as well save the database space. Or by contrast, wait a minute, going to have more than 2 billion users, success permitting. I'm going to therefore want to use a big int, like 64 bits, so I can have many, 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 many users or rows in my database. And indeed, some of the most popular websites out there have run into this issue, the Facebooks, the YouTubes, and the others of the world, where they just have so much darn data, they had better not cap the number of rows in their database table at only 2 billion, because they might well have that many and more. Then why not just choose varchar with a really big number? Why not choose big int with a really big number of bits? Well, it's wasteful, right? Like, you shouldn't over-allocate, because then you're just spending more space, and space costs money and might even cost time to search if there's more bits to be looked at. And so you don't necessarily want to just cop out and say, use as much space as you want or as is necessary, because again, we can't be as helpful, therefore, to the database. Now, numbers are an interesting one, and this is true in programming languages, whether it's SQL or C or C++ or yet others. It turns out that choosing how big your data is or anticipating it kind of has some real impact in some cases of numbers. So it turns out that a integer, of course, is just a number like -1, 0, 1, and on up in both directions. But a floating point value, or float, is a real number, a number that's not necessarily an integer, but a real number that has a decimal point and some number of digits after that decimal point that may or may not be representable precisely as a fraction. So that's a real number or a float. If you want more bits or precision than that, you can actually specify double precision, which gives you more bits, and therefore you can have even more digits after the decimal point. But the key takeaway here is that at the end of the day, it's going to be finite if you're representing a number. And so if you do use something like a float, even a double precision float, which gives you more bits of precision, at the end of the day, last I recall from like grade school, there is an infinite number of numbers in the world, both integers and real numbers for that matter. So in both the case of these integer-based numbers and these floating point values, you can only count so high, or you can only specify a number so precisely. And at the end of the day, you might have some overflow where you just can't represent bigger numbers, whether positive or negative, or you just can't represent enough decimal points, enough numbers after the decimal point to represent a number perfectly accurately. And so there's this trade-off. You might want more and more space, but at some point, you can't have an infinite amount of space. But computers are physical devices. They only have a physical amount of memory inside of them. You might have to draw a line. And so if you've ever seen some older movies like Superman 3, which has a great incarnation of this, or somewhat more recently, Office Space, where there's money-making scam whereby the companies in question, long story short, were constantly manipulating monetary amounts in their database systems, but they were always rounding off fractions of pennies. And so the masterminds in both movies started pocketing all of those fractions of pennies, but hilariousness ensues when they don't quite realize how much those fractions of pennies add up. But that, too, is an issue of imprecision. We in the human world, generally, when going to stores and such, use only 2 decimal points of precision. But investment banks and banks more generally might actually use more numbers after the decimal point than that. And so having the ability to express numbers more precisely is compelling. Thankfully, there does exist decimal, which allows you to specify how many numbers maximally you essentially want before and after the decimal point, or the total number in question. And so that would be an alternative to these others, but it might end up then costing you more space just to get that more precision. So here, too, as with the decisions around frameworks and libraries and languages, here, too, there's a trade-off. Even at this lower level, when you really get into it, deciding how to store your data in a database. Lastly, and a little more easily, there are data types like date and timestamp, which do as they say. They look like dates, they look like times, they look like timestamps, like just some counter from some preordained moment in time. And these data types are commonly used, as you might guess, to store these types of data in a database. When did the user last log in? When did he or she register for the website? When did he or she buy something from our catalog or the like? You can represent those and more data types in a standard relational database that supports SQL. But you have some other options too. It turns out that in a relational database, you can be even more helpful to the database by telling it in advance if any of your columns should be considered a primary key, or a foreign key, or a unique constraint. Now, what does this mean? Well, typically with data, it is useful to be able to uniquely identify a row in your table, in your spreadsheet, without having to look at the whole row. For instance, when using Excel or Numbers or Google Sheets, you'll notice that by default, all of the rows are just numbered, 1 through whatever. That's useful because if you are collaborating with someone or you yourself are just trying to find some value, you could just jump ahead to like row 50 to identify the 50th row of your data. You don't have to look for a specific name or address or purchase order or whatever it is that you're storing in this table. You can just jump to the row number in question. A relational database very often takes the same approach, using some piece of data, usually just an integer, 1, 2, 3, 4, just like these spreadsheet programs, to uniquely identify the rows so that you can access them very quickly via that number or that index. A foreign key, we'll see, is a notion of a piece of data that kind of exists in two separate tables, two sheets, where there's an interrelationship. But more on that kind of example in a moment. And a unique key, a unique column, is one where you should not see any duplicates. So for instance, maybe when building a website that has users register for your website, if you want to ensure that no user can have the same email address as another, you can specify to your database, hey, database, make sure that malan@harvard.edu, or whatever the user's email address is, only appears once in a column in my database. Don't let David or not David register with that same email address. And so this is a useful way to ensure that you have correct behavior of your website and you have integrity of your data so that you don't accidentally have, say, duplicate values, which would lead potentially to ambiguity. And there's even more features you might get from a typical database. But let's explore this by way of an example. All right. Okay, we'll cut that out. Let's open Microsoft Excel in this case, though we could use Apple Numbers or Google Sheets or any other spreadsheet tool for that matter, just so we have a tool with which we can lay out some rows and columns. And suppose that before I knew anything about databases, I was just using a spreadsheet to lay out a record of all of the orders someone placed with my local business. And I sell widgets and I sell sprockets, and those two things. And anytime I sell one of these items, either in the store or maybe on my website, I record it in this spreadsheet. Now, I'm going to be doing it manually, of course, at my keyboard, but suppose that this is actually being implemented, not with Microsoft Excel on my own keyboard, but it's actually being implemented with a SQL database and a programming language on the so-called back end, so that when a user does buy something via my website's front end, the HTML, CSS, and JavaScript interface, their order gets recorded in my database. And I'm just going to pretend that Excel is my database, even though, again, it's more likely going to end up in MySQL or Oracle or Postgres or something like that. So when an order is placed on my website, what do I probably want to store in my database? All right, suppose that a widget has been ordered. My instincts are to type in widget, and maybe the quantity that was ordered, so maybe one widget was ordered, and then maybe the person who ordered it, so maybe it was Ms. Zamila Chan, and maybe she works in, say, the computer science building, so 33 Oxford Street, and that was maybe in Cambridge, and that was in Massachusetts, 02138. USA, although here we have an example actually of an annoying Excel feature, but one that speaks to this notion of data types. Excel actually doesn't quite have data types per se. It instead has this data formatting feature where you specify how you want your data to be formatted. And you can see here, Excel thinks it's being helpful by simply removing leading zeros from numbers I type in. But I, the human, know, and I, the programmer, am going to know that, no, I want my zip codes to be 5 digits long, not just an integer per se. So I can fix this here temporarily by going up in Excel and specifying that my data, This is a waste of time. Let's just rewind and I'll fix this and undo this. How do I fix this? Format. Okay. Let me do this again if that's okay. Okay. Excel. What's the best transition here? Let me just rewind, and I'll just do this part again when I took my water break. So let's indeed now try an example whereby we decide how best to store data in my database. But to simulate my database, I'm going to quite simply just use Excel here. I could use Apple Numbers or Google Sheets or the like, or any spreadsheet program. But at the end of the day, I'm really just using this because it's a program with rows and columns. In reality, if I am a business owner and I have a web-based store and I sell widgets and sprockets on my store, the reality is I want to keep track of who has bought what, so I know what my revenue is, so I know to whom I need to ship things, and so forth. And so I'm going to pretend to be the database here so that we can walk through an example where we design this database, but realize that the actual data that's being inputted by the user into my website's front end, the HTML, JavaScript, and CSS user interface, is going to get sent to the server as by an HTML form, where my backend language, whether it's Python or PHP or Java or Ruby or the like, with some framework probably, is going to be ultimately storing it in a database. And that database in turn might be MySQL or MariaDB or Oracle or Postgres or something else. We're just going to focus on what any of those databases might, how any of those databases might potentially store the information. So someone has just submitted a form on my website. They've given their credit card information and the like, and therefore it is time for my website to store this information in a database. What am I going to store? Well, if they've bought a widget, I might type in widget, quantity 1, and maybe it was Zamila Chan who bought this widget, and she is at the CS building at 33 Oxford Street, and that's in Cambridge, and that's in Massachusetts in 02138, USA. So here's some information, therefore, that I might store. This is good because I know to whom to ship it. I know how many widgets I have sold, and maybe the price should be in there as well. So she paid maybe $9.99 for this widget. All right, now let's fast forward in time, and let's assume that someone else has visited my website, and they too have decided to buy a widget, but multiple widgets. We upsold them. So a widget was bought, quantity 2. This is, say, Rob Bowden, also in 33 Oxford Street, Cambridge, Mass, 02138, USA. And this one was a total of $19.98 since he bought 2 of them. So I've just been storing this data in sort of free-form format, but each of these columns clearly has meaning. So maybe this first column should really be called product. This one should be called quantity. This one could be called name. This is maybe street. This is maybe city. This is maybe state. This is maybe zip. This is maybe country. And this is maybe total. But even here, there's some opportunities for disagreement. This is a little US-centric, the fact that we have cities and states as well as zip codes. Indeed, it might be the case that zip codes don't all follow the same format. Indeed, even in the US, sometimes people write them with 5 digits, sometimes with 9 digits and a hyphen. So there's a design opportunity there. But let's drill in deeper as to what data type these various fields should be, at least right now. Let me make room at the top here so we can just make notes as to the data types. But in reality, these would be stored not in the table itself, but somewhere else in the database. What data type should product be? And remember that among our options are data types like these. Product. Well, it's not a number, so we can knock off most of these options. It's definitely not a date, time, or timestamp. So then it boils down to, is it a char or a varchar? Oh. So char is a fixed length field, so we have to decide in advance. It's going to be 8 characters, 16 characters, 100 characters, or something else. Varchar would mean we just know the upper bound. So, I don't know. Like WIDGET is 6. So minimally, it's got to be 6 characters. But then there's sprocket, SPROCKET. Not sure I've ever had to spell that word. That's 8 characters, so 6 isn't going to cut it. So maybe we do something like char 8. But there's a trade-off here. If I specify now that this field is maximally going to be 8 characters, then I can't sell anything with a longer name than sprocket. I could change the database size or the column size later on, but it's ideal to get these things right from the get-go and not to have to go back in and change your infrastructure or hire someone to come in and make modifications. So maybe that's a little short-sighted. Maybe it shouldn't be 8. Maybe it should be twice that, like 16. I don't know. And I'm not necessarily going to offer an answer here because it entirely depends on what data you're trying to store, what items you're trying to sell. This, in fact, now is even more wasteful because even though I'm now anticipating product names that are up to 16 characters, the char data type is going to use for every product name 16 characters, even if a whole bunch of those are blank because the word isn't long enough to need 16 characters. So maybe I would go for a variable length field, not char, but varchar, whereby the maximum length of my column should be 16 characters. But here, as in CS more generally, trade-off. Like it might seem like a win, like, OK, well, if the problem is I'm using too much space all the time, let me just put an upper bound. There's got to be some price you pay. There's got to be a trade-off. And indeed, there is. It turns out that a database can generally search your data more quickly if it knows the entire column is the same width. Long story short, if it knows that this column is 8 characters, 8 characters, 8 characters, 8 characters, it can use very simple arithmetic to jump mathematically from one row in that column to another because they're all the same distance apart, essentially. But if you have a varchar column and variable length, you can think of the column not as being perfectly smooth on both sides, but kind of jagged on one side. Some rows are short, some rows are long, and so you can't just blindly use simple arithmetic and jump 8 characters at a time if the length were 8, or 16 characters at a time if the length were 16. So it's a trade-off. If we want to be able to search through our product names quickly, might not want to use a varchar. So here too, no right answer. It's a trade-off. And it might not matter for small data sets. Indeed, probably doesn't if you don't have many customers or you don't have many products. But certainly on scale, these kinds of things matter. And even when building something that's not going to have that many users, just getting it right doesn't cost that much upfront time. The most important thing, I dare say, is to actually give it some thought and not just leave it to chance or take the easiest way out. Because invariably, over time, you will build up so-called technical debt, where you make poor decision, poor decision, poor decision, and now you have a very expensive decision later on if you have to go back and change a lot of those things. What about quantity? Well, quantity, nicely enough, would seem to fall more cleanly into one of these fields. Now, is it an integer? Is it a big integer? I think we're doing pretty well. If we need more than 2 billion products sold, maybe we're sort of a smaller shop and we can get away with an integer or even a small int. But this, too, would be a trade-off. How many bits do you want to spend? I would say that the default typically would be an integer unless you really are expecting a huge amount of data, billions of rows. So we might say something like integer here. Name. Oh, gosh, this is that can of worms again. How long is a maximum name? Maybe I do some Googling and some due diligence as the maximum length names. Maybe I just want to cut it off. You've probably been to a website before where you're happily entering your information and then you keep typing and nothing is happening. And that's because the programmer or the database designer has decided, your name doesn't need to be that long, or your address doesn't need to be that long. And it's infuriating sometimes because there are assumptions, naive, insensitive assumptions sometimes, but that boil down to perhaps either calculated design decisions or maybe just poor design decisions. So I don't know what is right here. 16 feels a little too conservative, so maybe I would say something like varchar 128. But even that, I'd probably want to take a look at my customer base and see if that's well beyond the limit of what I might actually need. Same thing for street, same thing for city. I don't really know what the right length is, but let's assume it's going to be varchars for those. So we'll just use a ... to suggest that it's an open question. State is an interesting one. If we expect to have only US customers, we can do a little optimization here, right? If every US state has a 2-character abbreviation, we could do char2 so that we get that performance benefit of knowing that every row is the same width, 2 characters, so long as we're comfortable not selling products to anyone else in the world beyond the United States. Zip code 2, design opportunity there. I think it's fair to say that integer, while seemingly correct, might get you into some trouble, at least here in Massachusetts, where we have a whole bunch of zip codes that start with 0. Like in the world of numbers and integers, leading zeros are meaningless. You can have as many zeros to the left of your number, and they don't change the actual value of your number. But in a zip code, it does have meaning. It is the first of 5 digits here. And so calling this an integer probably isn't very wise, because if the database is like most humans, the database might ignore that first digit. And so my zip code is going to appear to be 2138, which really isn't right. Now, we could fix that in code. We could make sure that, well, if we ever see a zip code that's only 4 or fewer digits, let's just prepend some zeros. That feels messy. If we're going to put the data in there from the get-go, let's make sure it comes back to us correctly. And so I might actually say something here, even though it looks like a number, maybe I would actually say it's a char5 field, or maybe it's 9 or 10 if I want to have a hyphen in there for US zip codes. Country 2, here maybe it's maybe it is going to be a 3-character abbreviation, a 2-character abbreviation. Not sure what's best there. Really depends too on what countries we want to sell to, if not just the US perhaps. So there's a design opportunity there. And then perhaps the last to consider is this total. I think it's fair to say that integer would not be correct, because we would either be rounding down or rounding up all of the money we're supposed to be collecting from our customers. So we probably want one of these. And some databases differ, but generally, a data type like decimal is ideal. You don't want to even get into the business of worrying about these rounding errors or errors of imprecision, as in Superman 3 and Office Space. Much better to just say that you want a fixed number of digits to the left and a fixed number of digits to the right of the decimal place, so that you are not losing even fractions of pennies or mischarging anyone or losing out in any way. So we might use decimal in that way. Some databases, though, have an actual currency data type, which operates similarly. All right. So there remains to be seen some opportunities for improvement. If I continue to sell widgets, let alone sprockets, I'm going to have more and more and more rows in this table. And if Rob and Zamila end up being repeat customers, I might have more and more Robs and more Zamilas in the same table. And as that happens, there begins to be quite a bit of redundancy. Indeed, what can you factor out over time? Well, certainly if Zamila and Rob keep ordering more and more items from my database, I could just keep updating the quantity, but that feels a little messy. It'd be nice to have a veritable history of all of my sales. I don't want to just aggregate everything. So adding more and more rows for every sale seems pretty compelling. But then I'm going to see Zamila Chan and Rob Bowden again and again and again and again and again in this table. And I'm also going to see their address again and again and again and again. And herein lies now the capabilities and the feature of a relational database. You know what I'm going to do? Rather than just treat this as my one and only table, let me go ahead and just rename this sheet or worksheet to be orders. But I could call it anything I want. And you know what? Let me create another table or sheet, and let me call this customers. So even though, again, I'm using Excel here, this is just like I might be doing in Oracle or SQL Server or in Postgres or MySQL or the like. I've just created a second table. But as per the name relational database, there's going to be a relation across these 2 tables now. And what's that relation going to be? Well, you know what? I'm going to go ahead and I'm going to be pretty dramatic here. Let me go ahead and remove all of that customer data, put it in this separate table here. Sorry, let me just zoom. One sec. Okay. Let me go ahead and copy all of this customer data and actually cut it and paste it over into this new table called customers. And now this isn't quite sufficient. I'm going to go ahead and notice that Excel has already numbered these things for me, but I'm going to go ahead just for clarity and add my own column, and I'm going to call this ID, and it's going to be, say, an integer. And I'm going to call Zamila my first customer, Rob my second customer. And in this case, notice, now these unique identifiers are part of my data. It's not just part of Excel's arbitrary numbering on the left and arbitrary lettering on the top. Rather, these are now actual pieces of data in my database that will be stored and backed up and so forth. But notice, now that Zamila is customer number 1 and Rob is customer number 2, each of whom lives at these addresses, I don't have to worry now about redundantly storing that data, because in my orders table now, anytime Rob or Zamila or some other customer purchase from my website, notice I can shrink this, and I can just say, you know what? Oops, sorry. And I can say, you know what? This is the customer who bought this. It's going to be an integer. And you know who bought that first widget? Well, it was Zamila. And you know who bought that second widget and the third widget too, since quantity was 2? Was Rob. And if some new customer comes into my database, so for instance, suppose that someone new orders from my website, they are going to become customer number 3. That will be, for instance, Doug Lloyd, and suppose he too is at that same address, just because everyone works together. Sorry. Infuriating. Continuity error. If we suppose some new customer comes to place an order, they become customer number 3. Maybe their name is Doug Lloyd, who just coincidentally happens to be at the same location in Massachusetts, at that same zip code in the USA. But now in my orders table, suppose that Doug has bought like 10 widgets. He really went all in. Well, he too is going to have widget there, quantity 10. His customer ID is 3. And he, of course, is going to have spent $99.90 with us in total. So notice how we've kind of factored out the common information to eliminate a redundancy. Notice now that if Doug or Rob or Zamila move addresses or change their address, or if we were storing more information like their phone number and email address and other personal data too, we could change it in just one place and not in our orders table, because indeed there's now distinct semantics. Our orders table stores orders. Our customers table stores customers. And if we wanted yet another table, as we probably should have, it could store, say, products. In fact, there's still this redundancy. Notice how we have widgets here. That doesn't seem to make much sense. Let me go ahead and create another sheet here, call this one products, and then go ahead and cut and paste the products information into that one as well. Pause. I gotta change this silliness. Oh, no, 10 of them. Okay. I think we're good. Let's create another. So let's create another table called products. And in this one, we could have a product ID, but then also a product. Let's go and create another table called products, in which is a column called ID, and another column that's called name for the product. Is that what I called it? Nope, let me do this again. Let's go ahead and create another table called products, inside of which is an ID field, as well as a product field. And then, just as before, let's start numbering our IDs from 1. So our first product is a widget. And while we've not sold any yet, our second product, ID 2, is a sprocket. And now in this case, in orders, can I store not product per se, but a product. Now in this way, in my orders table, can I store not a product per se, but a product ID. And so now, even though my table is frankly becoming more and more cryptic and a little harder for me to wrap my mind around, like what am I looking at? It's all just numbers. It is now what we would call normalized in the context of a database. And a database typically is not meant to be looked at by human eyes just like this. Rather, it's meant to be queried and data created and updated and deleted. And so there's certain commands in this language called SQL that actually facilitate programmatically, using a programming language, what I've been doing with my keyboard and fingers alone. And so, to get to that point, recall that there are these, sorry, my voice. I realize we're running low here. Indeed, the commands in SQL with which you would actually be doing this creation and reading and updating, deleting, is these four statements here. Indeed, these are the puzzle pieces, if you will, used in a programming language called SQL, via which you can actually query for data, update data, delete data, and more. And so, sorry. Ta-da. Okay, sorry. Indeed, the commands with which you can manipulate the data in the database itself is going to be SQL's commands: create, select, update, delete, and others. Indeed, much like Scratch has the various puzzle pieces via which you can implement logic in a Scratch-based program, so does SQL have these puzzle pieces, if you will, via which you can create and select and update and delete data from your database, just like I've been simulating by using Excel here and my keyboard. And indeed, some of these more sophisticated concepts, like primary key and foreign key and unique key, now rather start to jump out at us, because if we consider what my orders table now looks like, notice that it's indeed mostly numbers, but those numbers are essentially keys into another table. In fact, if you look at products, my products table has an ID column, which has unique numbers, 1, 2, and so forth. My customers table has its own ID column, and these are same numbers but different meaning. These are customer numbers, 1, 2, 3, and so forth. So in each of these tables, customers and in products, is that ID column a primary key for the customers and products table, respectively. Within each of those tables, it is that ID column that uniquely identifies rows. Zamila is and shall always be customer number 1. Rob is and shall always be customer number 2. Doug is and shall always be customer number 3. So those IDs, those primary keys, must not change. They must be invariant, and as such, they can be reliably used to uniquely identify customers, or in the context of products, uniquely identify a product. Or in the case of orders, we forgot something. It would seem valuable, if we continue this train of thought, to also have here in my orders table an order ID that should probably represent each of these orders, which is just going to similarly be an integer that just keeps track, really, of how many total orders have been placed. 1, 2, 3, 4, 5, 6, on up, all the way up to 2 billion, or best yet, even higher than that. But notice these other numbers now. The product column is no longer the name widget or sprocket. The quantity column, still just an integer. That's not anything to do with a key, even though it's also an integer. But customer is an ID. But it's not a primary key, nor is product a primary key here. In this context of my orders table, is product and is customer a foreign key, because those two columns are primary keys in 2 other tables. So within one table, if you have an ID, it should be generally considered your primary key, if that is the role it's playing, uniquely identifying your rows. But if that same number appears in some other table for the purpose of cross-referencing, really, is it a foreign key? And suffice it to say that in SQL, this database language, even though this looks rather cryptic to we humans, realize that with SQL, can you stitch these distinct tables or sheets back together? You can, quote unquote, join SQL tables in such a way that you can take your customers table and your orders table and reassemble them so that you see next to each order, say on your administrative web page that allows you to see all of your recent orders, not the customer IDs of who has bought what, but actually the customer names and their addresses and maybe their phone numbers and emails and more. You can join this information back together again. And what databases are good at is doing exactly that kind of joining, not to mention searching or more. But geez, this was like a lot of work just to get to this point, right? It was pretty easy to make one worksheet, just put all of my orders in there, but then we went down this slope of, oh, well, maybe we should factor this out. Oh, wait, we can factor this out. Oh, maybe we should add some IDs here. Like, we just created a whole lot of work for ourselves. Now, I dare say it will pay off over the long run, and indeed, our database will be much better designed, where better design will lead to faster performance, less redundant storage of data, and more. But it certainly took a lot of work. So it turns out there is the opposite of a SQL database that's been in vogue for some time, called a NoSQL database, or a document store, an object-oriented database, where the defining characteristic really is that it is not SQL. It does not store data in rows and columns. It does not store data in one or more tables that can then be joined. Rather, it stores all of your data really all together in a hierarchical structure. And that's an oversimplification, because there are other features. But consider this example here. This is written in essentially a format that's called JSON, JavaScript Object Notation. But this idea of a NoSQL database has no fundamental connection to JavaScript, the language. Just so happens this tends to be the language with which these data structures are represented. The curly brace here and here just means here is an object of information. The quotes are just used around words and numbers, and the colons separate keys from values, where keys and values is a very common paradigm, where on the left is metadata and on the right is data, typically, key and value respectively. Square brackets just mean an array, which means that this is an array or a list of 2 values, something, comma, something, which happens to be GPS coordinates, latitude and longitude here. So what is this? What are we looking at? This appears to be an object, shall we say, that represents the city of Alston, where Harvard's business school is, where Harvard's engineering school will soon be. And so this object contains a bit of hierarchical information, not a huge amount, but notice it has an ID, which happens to be its zip code, 02134. It has a city name, Alston. Has a location, which by convention is a comma-separated list of 2 values, latitude and longitude. And so that's kind of some hierarchy. It's not just a simple value. And then there's a population of 23,775 at last count, though surely to rise. And then in the state of Massachusetts. So this is actually a snippet from a database called MongoDB, which is a very popular NoSQL database that stores data essentially like this. So rather than flatten all of your data, as is the case in a relational database using SQL, an object-oriented database or a document store like this NoSQL database called MongoDB really stores things as key value pairs. And those key value pairs might actually have some hierarchical structure. So if you, for instance, stored an order like we just did, instead of storing it in rows and columns, you would just store it as one big chunk of information like this. And inside of that object, an order object, might actually be the entire customer. Inside of that customer might be his or her city and state, and so forth. So there might actually be retained in it some hierarchy like you see here. And so this is just a different way of viewing the world. It has typically been a more efficient way of viewing and modeling your world, because you don't have to give, frankly, as much thought to the design and the division of some of your data and the normalization thereof, but you do sometimes pay a performance penalty. You do sometimes pay a penalty in redundancy of data, though there are ways to avoid that by reusing something like that ID field. So it really is ultimately a different philosophy right now. And it's a competing alternative to something like a relational database. And here, too, will there be an opportunity to read up on and to debate exactly what is best for your actual problem at hand. And now, and lastly, mobile. We've looked and focused, really, at the front end, at the back end. Yeah. What did I say? Oh. Yeah, I don't, can we maybe just cut to the screen at that point and cut out that audio? Quotes around, okay. Key value pairs with quotes around strings. Something like that. Really just key value pairs. I don't think I even need to mention the quotes, to be honest. Yeah. Key value pairs. And I realized I'm going to port the relational example that we just did on the fly to a JSON object. So when I was standing over here and I said, as you see here, I will give us a new slide to interpose so that it looks like it was there the whole time. Okay, almost there. Rounding up the end. Okay. And now mobile. Up until now, we focused largely on the front end, on the back end of web-based applications that you might access on a laptop or desktop or even a mobile device. But And now mobile. Up until now, we focused on the front end, on the back end of really web-based applications that you might access on a laptop or desktop or even a mobile device. But what we haven't given thought to is the design opportunities for mobile devices specifically. Indeed, most any of you who have a smartphone these days, iPhone, Android, or the like, have probably downloaded some application that did not come with your phone. And you downloaded that from the Google Play Store or the Apple App Store, and that software is quite likely written in a very specific language. Indeed, the language for Android is typically Java, in which programs are written. The languages in which iPhone and iPad applications are written is Objective-C, or more recently, Swift. And so there, too, at least in the world of iPhones and iPads, do you have design discretion over what language you use, with Swift being the more modern and the one that Apple's really been pushing. But even then, do you have the option to not implement a native application per se, one that is implemented in Java or in Objective-C or Swift, all of which are programming languages. You can actually implement a web-based application, but package it up in a way that makes it seem like it's a native application, allows you to distribute it via the App Store, via the Google Play Store, so that it ends up putting an icon on your customers' phones, but when they click it, they're not seeing an iPhone application per se or an Android application per se. They are seeing really a secretly embedded web browser whereby your application is implemented at the end of the day in JavaScript and HTML and CSS, but it's got a nice little rectangular window around it so the users don't realize that they're looking at Safari or Chrome because all of the menus of those browsers have been stripped away. All you get is an embedded web browser. And so here, do you have an opportunity to choose among these options? Sorry, voice is going. This is the last slide. I know we're hitting the time limit here. And so one of the design decisions one makes when designing for a mobile user base is, do we develop an Android application? Do we develop an iPhone or iPad application? Do we do both environments still? And how do you choose among those? Well, it certainly depends on your demographic. Android is by far the most popular mobile operating system these days, but in certain contexts, a campus like this, iPhones are actually even more popular. So do you want to cater to one demographic or another, or ideally both? Both is probably your instinctive answer, but that comes with a trade-off. That certainly comes with a price. If you want to ship some new and improved tool that you want to make available to the world, or a game or any other piece of mobile software, well, it'd be nice to have it available to all users with smartphones, but then you're going to have to know how to program in Java. You're going to have to know to program in Swift or Objective-C, or you're going to have to know how to take this hybrid approach of developing it using JavaScript and HTML and CSS, but there too there's a trade-off. You tend to get very good performance out of Android applications that are natively written in Java and native applications in iOS that are written in Objective-C or Swift. They just tend to be very responsive. They tend to follow a very similar paradigm. Menus and buttons and so forth all tend to look and feel the same and therefore be familiar to users. And they're very responsive. Touch a button, something happens quickly. There doesn't seem typically to be much latency. In hybrid applications that are really written in JavaScript, HTML, and CSS, especially if they're technically server-side, hosted on your servers or in some cloud server, they might actually feel a little slower because there's a whole internet between you and your user's experience. Or they might have to download more data that would be better to just bundle up in the application itself. Or the menus and the buttons, they don't quite feel as native as the default Android and iOS user experiences. So a bit of a trade-off there. OK, so if you don't want to pay that penalty of performance and perception, implement the Android app and the iOS app. But now you need 2 developers or 1 developer who knows both platforms. So that too comes with a cost, both in time or salary or talent or the like. So there too, it's not obvious how to go. And even more recently, are there frameworks like Cordova, Ionic, Meteor, React Native, Supersonic, Xamarin, and more that actually offer yet a 4th option, whereby you implement your application in some neutral language like JavaScript. And then using these frameworks, these tools that other people have kindly or commercially developed for us to use, you can essentially convert or translate that middle language, JavaScript, to Objective-C or to Swift or to Java or really to the underlying code that gets shipped ultimately to the app stores so that you can actually develop native applications but in an intermediate language. But there, the learning curve might be a little higher. Indeed, the menu of options is even longer than the list of native languages itself, so that requires some learning curve or some time or talent or money again. And so there, too, there's some trade-offs. And so it really depends ultimately on what is your application and who do you have working with you and what is most important and how much time do you have and what do you view the technological horizon looking like some months ahead. So at the end of the day, these technology stacks, as they're called, are really just menus of options. And those menus are constantly evolving. And they focus on the front end, on the back end, on the server, on the client, on mobile devices, laptops and desktops. There are solutions to any number of problems. And so part of the process of building a solution to a technologically motivated problem, building an app, so to speak, really boils down to initially doing some due diligence, reading up on and educating yourself on what the design decisions are ahead, asking the right questions of the engineers with whom you're working, and ultimately making not necessarily the right decision, but one of several possibly right decisions, all of which might have some upsides and downsides, and indeed give you the same end result, but at different prices, but at different time frames, and with different, I did it again. And with different, I just need to finish the sentence. Different times, right? Different. Let me finish that sentence again. What's the best way to do this? Different. Is a menu of options from which to choose. What's the best way to fix this? So at the end of the day, what you indeed have is this menu of options, of languages, of libraries, of frameworks, of demographics whom you might want to target, of database backends that you might want to use, and so many more possible decisions. And so indeed the process of software engineering and developing a product and developing a web app or a native application itself is first doing some due diligence and bringing yourself up to speed on what the design possibilities are, having a discussion, having a debate even with the engineers with whom you'll be working, and ultimately making the most informed decision that you can with an eye toward what is trendy now, what has been trendy, and where the industry might be going, but ultimately focusing on solving optimally your own problems and choosing among these various and ever-changing technology stacks. Okay, so in terms of the notes you wanted, I'm going to send us an updated slide that will replace the latter half of showing the MongoDB JSON object, and it will be a customer's database example that I'll port to that format. We need to replace my last remarks with that last redo. And I think I did some Excel futzing, but along the way I made verbal mention of it each time I reformatted stuff to hide the bugginess of the data display. Correct, and we can also cut out my mention of quotes for strings and numbers and just say quotes or not mention it at all. I think my back was turned anyway. No, it's still going to be there, but I took care to, when I did this, and I said something about, as you see before you, I stood far enough away from the TV so that we can hopefully just cut to a full screen at that point, or do picture-in-picture where you see a new slide that doesn't exist. So it will be added after that slide, not replace it. All right, those of you who've actually tuned in this long or are watching this later at home, thanks so much. This was class number 5 for CS50 for MBAs. We've got one more coming up this Thursday, most likely. Hope to see you then, or otherwise in a few weeks when this finally ships. Thanks so much to CS50's team. We'll see you next time.